about just everyday users who just want the app to run, then they're not going to do this kind of stuff.
Yeah, but that would be the point of a smart server.
Yeah. But then again, you have the issue, can I trust the server?
I have a question. What are the risks with the licenses that you are using in your product? For example, OrbitDB has a permissive license, but what happens if they change their license to a more restricted one? How will this be handled in your product?
That is a very good question. Do you mean like the less restrictive in the sense that there is more debate? So if it becomes closed source, for example.
Exactly.
Okay, on the one hand, I already have a copy of my machine. I don't know, I hope it's not, because I see that the community behind IPFS and OBTB and it's the entire mentality is open source, so I think it's unlikely to happen. If it does, I don't know.
Okay. I'm not exactly sure of the answer, but as far as I know, for example, OrbitDB version 1.0 has the MIT license, but if they change it from version 2.0 and make it more closed source, then you can still use 1.0 so that it preserves the license that is there.
Yeah.
So this might be a solution, but I'm not really sure that there are any.
So there is another experimental application like this which also uses OrbitDB, and what they've done is they forked the project and then they actually kind of moved it to Go implementation. So originally it's TypeScript, they took the code and they just translated the whole thing to Go and said, okay, this is ours. I'm not going to.
All right. Thanks.
Che cos'è siamo a destra? Tu si din capulare ala pe tine e să miști capul asta. Da, acum merge și oare unde era lui? Etablă? Acolo e linkul? Acolo n-am mers. Dacă deschide asta, should work. Da, nu așa este. Dar să scos prezentarea. Altfel se vede partea de prezentare. Fără. Am și scris. Fără de fără. Ideea e că se tot schimbă cu partea de mașină. Și eventual, dacă vrei să se modifică. Poți descrie?
Da.
Să fie iar.
Oare nu știu
Nu e copiată, e strict?
Da. Mi-am dat seama târziu că trebuia să le Ok. Bine.
Skip signing. Skip signing, okay. For fără asta.
Dar dacă e duplicate,
Da, numai că știi și rămite asta. O să se poate ce vreau să spui de se reprezintă cu ei.
am înțeles.
Our next presentation belongs to Mirna Cristina, COVID-19 exploration and prediction using machine learning.
Okay. Hi everybody, I'm Mela Cristina and today we'll talk about COVID-19 exploration and prediction using machine learning. So we'll start by examining the problem statement and how other people try to solve this issue and my proposed solution. We distinguish three main reasons for choosing this topic associated with machine learning: need, opportunity, and my curiosity. So the need for innovation and discovery was driven by the urgency of this pandemic because the major number of cases and the high mortality of the disease. And this was the best opportunity for data collection. The data that we're going to analyze is a data set composed of 1,617 patients that were admitted to the Clujana Hospital here in Cluj with a positive COVID-19 diagnosis. And we'll try to answer the following question. How can we interpret COVID-19 data and predict the outcome of a new patient based on it? So, a patient comes into a hospital and the medical staff tries to make an assessment based on some of its features, like age, gender, comorbidities, and so on. We want to make a prediction based on the present state of a patient, taking into account the last patients that we had into the hospital. But as we may see, 82% of the data set contained the outcome improved, so we may label the data set as unbalanced. What can we do in this case? We couldn't let the data set like this because it would lead the model to overfit and would lack the needed generality for the problem. To answer this issue, we needed to acquire the proper technical understanding. So we try to make an artificial neural network to predict this possible outcome that I've talked about, and the medical prediction is next. So some papers talked about some key factors that took part in the risk associated to hospitalization of COVID-19 patients, such as comorbidities like heart, lung diseases. As we all know, older age comes with a lot of comorbidities. We may say that it is tightly linked to the risk factor, and some studies also found that the male gender may also be tied to the risk factor because males are let's say have a reckless behavior like drinking and smoking sometimes that could affect the lungs and the liver. And other studies found that some test results like the C protein reactive level could potentially show the severity of a patient, and this fact was also backed by the Clujana Hospital from which the dataset is taken. Review of the literature. Some papers found that there is a strong relationship between the comorbidities, as I said, and the risk factors, but these studies focused on only two outcome groups. And other papers talked about some laboratory parameters that would correspond to the severity, meaning that it were positively or negatively correlated, but our data set did not show the same correlation. And in the first graph you may see that in a paper there was analyzed the age based on the effect and the mortality in COVID-19. But in the second graph, you may see that the distribution is not the same in our data set, and this fact is attributed to the unbalancing of the data. So, because 82% of the people are improved, the data set is not skewed as in the first graph. Methods and procedures. The initial dataset contained three types of columns: numerical, categorical, and free text data. The numerical values did not need any pre-processing. Categorical values such as gender were mapped to numerical values like female to 0 and male to 1. And free text columns, the most interesting ones, were composed of a sequence of data separated by a set character, and these type of columns were treated with a one-hot encoding procedure. But the comorbidities column, here we found 1,400 unique comorbidities. So it was not a good idea to use one-hot encoding for this problem, since the data set would become too large and we have too many Boolean values for what we wanted. So we came up with a formula based on frequency and the set bias. This formula was computed by using the below table. For each comorbidity, we used the frequency of the number of patients from each release date. And the bias was set -1 for cured till 1 to deceased, so that the model would better discern between these numbers. Adding to this idea, it was crucial to treat the overfitting and the unbalancing data with more and more techniques. So we used an adaptive oversampling technique to add synthetic features. After each dense layer, there is a dropout layer that would cancel any unnecessary weights, and we tried using an optimizer for the learning rate. The adaptive oversampling algorithm that was used is ADASYN, that is very much like the more common ones, MOTE, because it is also based on a KNN algorithm. But the main difference is that it takes into account the local distribution of the initial classes. Besides that, the best solution was to make special percentages for each label so that the initial difference would remain fairly the same as in the final dataset. The proposed model contains three dense layers following 3 dropout layers after each one. Each layer, the dropout layer have a Gaussian noise function that is perfect for this type of overfitting problem. Each layer has an exponential, SELU and ELU activation functions that were all tested using a heuristic method. So all models were trained, and after that the results were compared. The performance of the model. If we take a look at the loss function, we can see that the mean squared error of the model goes as low as 0.5%. And after looking at the confusion matrix computed on a new set of unseen data, we may conclude that the model makes fairly good results. It has a good accuracy because most of the values lie on the first diagonal, and the final and best model had 80% accuracy with 18% F1 score. These results are compared to some examples proposed in the literature, but we should take into account that these examples have a much larger data set, but they have less features, and they took into account only 2 outcome classes, not 5, as in this study. In conclusion, we should be aware that this data set was handwritten by humans, so it comes with its errors and biases, And thinking that the labels should be equal is foolish because this is not the real world. In the COVID-19 cases, only 0.01% worldwide ended up in deceased. So to balance the data 20% was not the solution. And yeah. An artificial neural network is a great solution for any tabular data problem. And for the future work, I would suggest to have a better feature selection algorithm, maybe based on decision trees, randomize the data set between epochs, and maybe introduce an unsupervised learning algorithm that would relabel the data before oversampling it, and maybe not oversample the data at all if the data sets are equal. This was my presentation. Thank you. There are actually real records from the hospital, so yeah, real patients, but I acquired them through an internship. So it wasn't really difficult for me personally, but I'm sure that it is like the most difficult step. I crossed the bridge very easily.
It's a good idea.
Thank you for the question.
Other questions?
Our next presentation is done by Dulce Patricia Georgiana, Platform for Assisting Commercial Law Communities.
Hello, my name is Dulce Patricia Georgiana and I'm from Babeș-Bolyai University, and today I'm going to present my paper, which is Platform for Assisting Commercial Law Activities. Here is the table of contents, and I will skip right into the focus of the paper. As an introduction, the manner in which commercial law is applied impacts directly companies' approach towards obligations and varies from country to country. Thus, we want to propose the software solution for Romanian commercial law number 85 per 2014 regarding insolvency and bankruptcy. As a state-of-the-art of assisting commercial law activities, we first want to mention that the system of Romania is very corrupted. And in order to respect the fairness of the commercial law enforcement, Romanian companies may need a procedure that automates the way in which they are assisted by court decision taken by the syndic judge in a commercial case. The problem that we want to overcome has four main aspects. To reduce the physical contact between the syndic judge and the client, to generate the judge decisions using templates for each type of court decision, to eliminate the bureaucracy of manually collecting documents, and to focus on Romanian commercial law enforcement and provide a solution in this case. The related existing solutions are not one-to-one with what we want to present, but they are concentrating on detecting legal text and by using random forest machine learning techniques and deep learning. And the second one is trying to use NLP in law case text publishing, and is using random forest, and it has an accuracy of 83% by using this method of text categorization. Because a file of a legal document can fall under multiple categories, we found out that multi-label textual data classification is the most valuable method for developing supervised learning for the set of legal documents. The methods of multi-label text classification that we want to use, are the problem transformation using binary relevance classifier, label power set classifier, and the sample, which is using the classifier chains. The challenges that we encountered in solving this problem was the first step, which is the data collection, which was a huge step in this case. We had to pre-process the data and find a suitable ML algorithm in order to train the model that wants to validate the fairness of a legal document, and next to develop the web application. In order to understand our approach, we first had to understand the law and to discuss with the legal expert. And we found out that this commercial law of insolvency and bankruptcy has 4 types of verdicts. If the company has a debts in amount of 50,000 lei or higher of 50,000 lei that have to pay in 60 days, the company can open an insolvency proceeding, can make a request to open an insolvency proceeding and could have a sentence in this case. If the company has approved that has debts higher or equal to 50,000 lei, but didn't pay the stamp duty of 2,000 lei, it goes to a postponement sentence. The company could refile the application. If the company has debts in amount of less than 50,000 lei and didn't pay the stamp duty of 2,000 lei, it goes to a rejection verdict. And if the company somehow proves that it doesn't have enough money to pay the debts, it goes directly to bankruptcy. Our application is intended to be used by 2 types of communities, both legal fees and the administrative side of a commercial company from Romania, and is written in Java using Spring Boot and has a multi-layered architecture. The main two flows of our application are the client flow and the judge flow. The main functionality of a client is to upload the necessary files. It confirms the data extracted from the documents and is redirected to messages displayed for accepted or rejected requests. And now waits for the syndic judge to generate or upload a template for a particular court decision for his client. Okay, software system. Our software system has a web main application that communicates with two server-side applications, which are written in Python, both of them, and one is for parsing the documents and one is for predicting and validating the court decision. The collection of the data set, as I already mentioned, was a huge step. And we first wanted to see which are the relevant data. And we saw that we want court decisions and text of court decisions. So we first gone to onerse.ro site, which was not available one. Next to Portal Just, next to info.sat, and next to Regius.ro website, which had the data that we needed, which were court decisions. Next, we needed to pre-process the data. We collected over 1,000 court decisions from this website, and we managed to generate 1,773 text files that contain court decisions. And we also augmentate the data and generate dummy text, ghost words. And we have a dataset distribution that looks like this. And as I already mentioned, we had multi-label classification. So there are multi-class, our data set is constructed with multi-class. Okay. The process of building and training multi-label classification model was first needed to parse the data, eliminate stop words from Romanian language, convert the words into numerical numbers, split the data set into train set and test set, use problem transformation as already mentioned, and to create an our model, and next to fit the model. Yeah, as I said, the data set structure looks like this. Okay. Okay. As results, we tested our results by using three different techniques, which are k-fold cross-validation, classification reports, and next you will see the confusion matrices. And we use the three different classifiers, which are binary relevance, label power set, classifier chains. And from our result, we arrived to the conclusion that the label power set has the best results. And here you can see the confusion matrices of each classifier, and it looks like this because, as I already mentioned, the court decision could fall to multiple classes, like a court decision could be admitted and an opening proceeding to it, or an opening proceeding of insolvency of the person for the person. Okay, conclusions and future work. As a conclusion, we wanted to eliminate the bureaucracy of manually assembling elements. We wanted to provide a software solution for Romanian business law in order to respect the fairness of correct court decision and to validate its fairness. And we somehow managed to do it. And as future works, we want to deal with bankruptcy cases because for the moment we have this thing hard coded in our application. We just deal with insolvency. And next, we would like to provide a mobile application for our users. Okay, thank you for your attention. Any questions?
Can you tell me again the accuracy of your algorithm? I saw that it's really high in the paper. I just wanted to make sure.
Is very high.
I'm not sure if I understand it correctly, so that's why I asked.
Okay, so for the label power set, because this is the classifier that we wanted to use, we had an accuracy of 93%, but for example, it always it has 100% for postponement.
Yeah.
Because here we collected the
Well,
most of them,
most
yeah,
of them
as we
are-
could see the data set distribution, the most of them are postponed.
Great work. Other questions? Thank you.
Thank you.
The next presentation will be held by Alexandra Salukian, out-of-band network management system proposer.
My name is Alexandra Salukia, and today I will present out-of-band network management system proposal. The table of contents can be seen on this slide. Okay. A network management system is a vital tool to be used in a corporate network. It ensures that quality of service, known as QoS policies, are correctly applied. It has an impact over the network security, preventing attacks and blocking the ongoing actions of attackers in enterprise networks. Companies all around the globe provide cybersecurity courses to their employees in order to prevent hacking. As individuals, we are the weak link when it comes to security, so the hackers uses our vulnerabilities and weaknesses against us. The current work presents an implementation of an out-of-band network management system with the primary purpose of detecting and blocking ongoing domain name system known as DNS exfiltration attacks, which are triggered by other hosts in the network. As a secondary purpose of the network management system is to adjust the quality of service policies of the other devices in the network, manipulating the value of the differentiated services field of the IP packets. Also, as purposes are to define the protocol communication via TCP sockets and to deserialize the packet data in order to determine the source IP addresses. SharpPcap is a library well known for accessing the WinPcap capture drive in .NET for decoding and analyzing the network packets, and is a programmatically way to do what one can do with Wireshark. Working with .NET and SharpCap, one can list a network device, capture packets, filter them, and have the benefit of Microsoft support. Technologies of quality of services, accomplish network ability to dependably run high or low priority applications, and traffic under limited network capacity by providing differentiated handling and capacity allocation to specific flows in the network traffic. The order in which the network packets are handled and the amount of bandwidth of traffic can be programmatically set by changing the DHCP field on each computer. The value of this field is stored in the computer registry as it can be seen in the image. DNS exfiltration is a way to exchange data between two computers without any direct connection. The data is exchanged through DNS protocol on intermediate DNS services. A response back with a record which allows a large amount of unstructured data to be sent between the attacker and the victim can be autonomously detected and declared malicious. The DNS traffic is not encrypted and is also legitimate network traffic. In the image, it can be seen that in a system there can be two DNS servers, one a legitimate service and the other one the attacker service, which can alter the data on the router in order to make the data to be sent to it. The proposed system, the system is architecturally composed of a main computer, which represents the monitoring device, one or more computers, the traffic of which is being monitored, a switch and a wiretap, which duplicates the network traffic data to the monitoring device for out-of-band management. In the figure, we can see the monitoring device, which has installed in it an application which monitors the data, and two computers that are monitored having installed another application which accepts connection from the monitoring device application. The communication protocol: if a virus runs on any computers that attempt to steal data through seemingly legitimate DNS requests, which in fact attempt to exfiltrate the data, the monitoring device will take action accordingly. The client application is continuously running, as I said, as an operating system service process waiting for a connection from the monitoring device. The client application can receive two types of commands: to change the differentiated service field value for the next IP packet, or to disable the network adapter in order to block the ongoing malicious requests. The type 1 of the protocol is only a warning packet, which suddenly will result in a blocking packet. As testing methods, I used three ways of testing, which are presented next. One, running on the local machine and implementing TCP sockets on different IP addresses of the loopback range of IP addresses. Running on the same computer with virtual machines with bridge network adapters created to simulate different devices in the same local area network. And one which is running in the real hardware setup using two laptops, a home router, and an Ethernet wiretap. One of the computers is the monitoring device, and another one is the monitoring computer, as it can be seen in the picture. The testing methods were supported by the Wireshark captures. We can see in the registry that the value of quality of service is changed to 14, which is also sustained by the Wireshark capture. We can see that the value of the packet of the quality of service is also faulty. As conclusions, the main objectives achieved are to detect and block the ongoing DNS exfiltration attacks, adjust the quality of service policy of the other devices in the network, manipulating the value of the differentiated service field of the IP packets, and also to publish the work done through scientific article at this conference. Thank you. Any questions?
Okay, so the presentation was very interesting, but I didn't get how exactly do you differentiate between legitimate DNS traffic and DNS traffic that is meant to exfiltrate data. So what are your heuristics, or what is the actual method for discriminating between the two types of traffic?
Yes, at this point, I get the request, and for the type 0, which is for quality of service, I just look for a word, a keyword. For the type 1, which is of warning packets, I'm looking at the length of the request, and for the blocking, I'm looking for words that are stored in a dictionary taken from GitHub, like with the most common passwords in 2020.
Okay.
Yes.
And my question is, could your system be used like against itself? What I mean, if the actual system is compromised, will it affect the computers that it's trying to monitorize? Because that's exactly what happened for Microsoft on their Exchange service at one point. And I'm just curious if you ever thought from this perspective.
Okay. Compromised in which way?
Can I read it?
Compromised in which way?
Somebody else than you has access to the actual system and can do anything there.
I never thought of this at this point, but I guess only that can be changed are the ways that the protocol works, like I explained previously. I don't know, it can change the words or so, or the dictionary to another words. But, yeah.
And if you were to secure it, what would you choose, perhaps?
Okay, this was out of the scope.
So yeah, it's
I
like
never
future
thought,
work.
Yeah, as a future work, to secure it. I don't know.
It's
yet.
complicated. No problem.
Yeah.
I was just curious. Thank you.
Other questions?
Thank you.
Yeah.
Așa. N-am dat așa mă. Poftim? Nu am online.
Our next presentation belongs to Caio Constantin Tiberio and is called Auxiliary Diagnosis for Canine Hip Dysphagia Classification based on Norbert Hip Angus identification. application using convolutional neural networks.
Hi, so my presentation is structured as follows. First, I present canine hip dysplasia, how it's classified, what the criteria are, the motivation for choosing this topic, the related work in this field, my proposed approach, and conclusion, future work, results, etc. So, canine hip dysplasia is the most common hereditary orthopedic disease. It affects virtually all dog breeds and can lead to gradual loss of function in the members. And it's very important to identify hip dysplasia in time and classify it correctly, because since hip dysplasia has a hereditary aspect, dogs have to be removed from the breeding pool. Well, one criterion proposed by the FCI for hip dysplasia classification is represented by the Norberg angles. So, as that image shows, I'm not really sure if you can see it that well, but there's that arrow there. It basically shows the Norberg angle for the left hip, which is given by the corresponding acetabular rib and femoral head, and the opposite femoral head. Calculating the angles takes a lot of time, because doing it manually, as happens in Romania and other countries, needs you to use calipers to find the center of the femoral head, and afterwards use a protractor to compute the angles to compute the Norberg angles. Furthermore, based on some experiments, when measuring the Norberg angles manually and repeatedly, you may have some large differences that seriously affect the final classification score. In the field of canine hip dysplasia, all of the related work is basically classifiers. So they classify the hip. Given a hip, they classify it into either the classes from A to E, as happens in COP, or a binary classification. For example, AB for hips that show little to no signs of hip dysplasia, or C to E that show signs of hip dysplasia, and the dogs that have those hips should be removed from the breeding pool. Well, as you can see here, I've also presented some metrics the authors have shown. Well, my proposed approach is this. Instead of automatically classifying the hip scores, I am looking more towards auxiliary diagnosis, predicting the key points for the angles and then computing the angles. Because doctors may not be that approving of a black box model which automatically classifies something without offering explainability. So, let me just go forwards. The dataset I've obtained was received from USAMV Cluj-Napoca, so that is the University of Agricultural Sciences and Veterinary Medicine. And I've also obtained images from the internet, 137 images, an 85%, 15% training test split, kind of normal. And the images were annotated based on advice from trained radiologists. And when I say annotated, I mean I've marked the key points for the Norberg angles. Given that I had a very, very limited data set compared to the classifiers from the related work, for example, they've had data sets of upwards of 11,000 images, I carried out extensive data augmentation, flips, rotates, noise additions, etc., for a total of 2,472 images. The first model I created was a resonant model, a resonant 50 model, pre-trained on the ImageNet dataset. This model was obtained from the Keras framework, and so basically I did not use just the model, but I also added my own dropout layer, 2 dense layers for prediction and further processing. The model outputs an array of 8 elements, which represent the coordinates of the 4 points. So x9 coordinates of the 4 points, which gets us to 8 values. Furthermore, I use the UNet model, which is not based on direct key point regression like the resonant model, but is based on heat map prediction. As you can see here, the left image represents the annotated radiograph, and the right image represents the heat maps for the annotated radiograph. Although it's not really clear here, there are 4 heat maps present, but they are very close to each other, so you can kind of only see 2. I've chosen this model because in the field of medical landmark localization, Bayer in 2016 used UNet successfully and obtained state-of-the-art results. Here are some experiments I've done. As you can see, the first row of experiments, has the best results, which is a big. Well, I've seen a great improvement in performance after adding the flip augmentation, just horizontally flipping the image. So yes, on the left we have the experiments, and on the right, for the best performing models, we have the absolute angle difference. I've separated this on left and right hip because there is a significant performance difference between the predictions on the left and right hips. Also, if we go by the FCI criteria and separate and classify the angles into the classes, the AP classes, we have this 3 possible classes: A to B over 100 degrees, C to D 90 to 100 degrees, and E under 90 degrees. Well, these are the metrics. As you can see, the UNet model has fared much better than the resonant one, and the resonant model does not predict any of the hips to be of E class. One comparison with McEvoy et al. From 2021. I've compared the ability of the models to classify the hips into class C, where the models I've proposed have fared worse than the McEvoy et al. Model. However, this might be caused by the very limited data set I have acquired, and this might change with obtaining a more varied and larger data set. Also, I've compared this with the binary classifier of Gomez et al. In 2021, where the models I proposed have also obtained the lower classification accuracy, except for the UNet model on the left here. So, talking about the models, the resonant model performs worse on unhealthy hips. Here we have the same radiograph on the left with predictions from the resonant model, and on the right with predictions from the UNet model. The resonant model has the same predictions as would be normal for a healthy hip, which leads me to believe that it actually has done the configuration for the healthy hips, which were the majority class. Furthermore, both models perform worse on the right hips. While the results are promising given the limited data set obtained, they are not yet ready for medical usage because, well, for example, the UNet model has an 11-angle mean difference between the predicted and true value for the right hip angle, which might move the classification down from a healthy hip to a severely affected hip, which is not great to say the least. So, for future work, I would like to explore a larger data set, more varied with images from different imaging centers. I like to create a model that extracts the left and right tip areas, as was done in some related articles, in order to remove the noise from X-rays. I'd also like to experiment with more data augmentation techniques. And there's also another architecture proposed by Pyre in 2020 that I'd like to experiment with, as it has been shown to obtain marginally better results than UNet on medical key point landmark localization. And yeah, that's about it. Thanks. If you got any questions? Oh, sure.
So I'm not sure if I understand correctly why one hip performs worse than the other.
Yeah, good question. I'd like to investigate that further. I'm not really sure myself where this happened, and in this day, after I added the flip augmentation, my results improved considerably. So this might be related somehow, but I actually haven't been able to find a reason for this. But I'd like to try with a larger data set and see if this problem persists. Yeah. Any other questions?
Has your model been validated because you probably obtained some data from the agriculture university? And did any veterinarian actually try to use your model? And
yeah, we discussed about it. The results are promising at the moment, but as I said, there is this angle difference, let's say, and it's not yet ready for medical usage. Might be, but we need to obtain a larger data set, and it would be great if the model, if the images were actually annotated by radiologists, as I annotate the images myself under their advice. But having the images annotated by the radiologists might lead to better accuracy. Okay. Okay, cool. I'll just. Take a coffee.
The next presentation belongs to Tornado is all public transport vehicle detection based on internet.
Hello, my name is Dragos, and this work is about object detection in the context of public transportation. The main motivation behind this is that, according to the World Health Organization, there are around 200 million people that suffer from some form of severe visual impairment, meaning that they're legally blind, and also main need for human life is mobility. Like in order to have a good life, you need to move around, and the traditional ways visual impaired persons do this are through assistance dogs or walking canes. The problem is that the assistant dogs are really expensive, and they are really not enough to satisfy the need. Therefore, we propose a method based on computer vision and object detection. The idea is that a mobile device could detect objects, more specifically buses or cars, and relay this information to the visually impaired person in an audio form. Some similar methods include some opera classes that uses artificial intelligence in order to detect objects around in the surroundings, or on a mobile phone add-on that also can perform object detection, but the problem with these solutions is that they are not scalable because they imply extra equipment and they're also kind of expensive. We try to do something like this, but only on a mobile phone, which is more accessible to anyone. In order to implement our method, we follow the you only look once methodology, meaning that we have a single convolutional neural network that is trained end-to-end, and which makes the predictions. The key takeaway here is how we represent the output. Basically, the image is split into a grid cell, and each cell can predict several bounding boxes. Each bounding box is composed of a localization part and a classification part. Basically, it tells the location and the class of the bounding box. For the dataset, we use the open images before, which contains a lot of classes, but we only use a subset composed of buses, cars, and license plates. An initial problem with this dataset was that it is unbalanced, and we tried to address this issue by undersampling and by enhancing the dataset with license plates bounding boxes by applying a state-of-the-art object detector and automatically extracting license plates and inserting them into the dataset. We also generate over the dataset a set of anchors using k-means. These anchors help in training because, as I said before, each cell predicts a number of bounding boxes, and during training, for each cell, each bounding box is associated with one of the anchors. This is the pipeline of our approach. Basically, the image is taken from the live input of the camera. Then it is passed through the object detector, which computes the bounding boxes and the objects, basically. Also, the image is passed through an external OCR service in order to detect any text present, such as the license plate number. Then all this information is converted to a text format. Then it is played to the visually impaired person in the form of audio, and all of this happens on the mobile. Apart from the OCR, which is an external API. We delve deeper into the object detector, which we implement and train, and it is implemented along the lines of YOLO, which we discussed earlier. Important part, so we have kind of like two paths. The main path starts with augmentation, which is really important, pre-processing. Then we use transfer learning with MobileNet. Basically, we take a pre-trained model on ImageNet and we use it as a feature extractor. Then we add a U-shaped make, which takes layers from the pre-trained model and basically brings features from earlier layers into later layers in order to allow the network to see at multiple levels, at multiple resolutions. Then we use a convolution in inverted residual blocks, similar to the ones in MobileNet. And in the end, the predicted bounding boxes are outputted. The second path helps in training. It's an implementation trick which helps in computing the loss. Basically, during training, all true bounding boxes for an image are passed, and during normal inference, just a dummy array can be passed. For the data augmentation, we use some photometric augmentation, which are implemented by default. The ones that we implement are the cutout and the mosaic. The cutout basically puts a black patch on the image, and its main purpose is to make the network see objects even if they are not seen completely, if they are not visible. In mosaic, we take 4 images and combine them into a single images, as we can see there, and the bounding boxes are scaled accordingly. Basically, this allows the network to better see the smaller bounding boxes, because there are 4 images in a single one, therefore the bounding boxes are smaller, and the network adapts to seeing smaller bounding boxes, and this especially helps in detecting the license plates, which are usually smaller. These are the results. We use mean average precision, which is our implementation of testing is based on the Pascal coefficient implementation. Okay. We also develop a mobilized application which acts as an assistive proof of concept for an assistive technology. These images are from the static part, which detects only images. We can see the OCR on the left and the bounding boxes. The light speed is around 5 frames per second. In conclusion, nowadays the artificial intelligence models are more data-oriented rather than model-oriented as they were in the past. So definitely improving the data set would bring several improvements. Also errors in annotations also cause errors in the output. And on the mobile side, the main thing that can be improved is the conversion from bounding boxes to audio. Like as it is now, the bounding boxes are directly converted to audio, to a text, but maybe a convention would help in making the audio more concise. Okay, and now I have a little demo.
Two buses, 1 car, 2 buses.
Basically, it can detect objects. This is the live, the simple live functionality.
1 vehicle red showing up. CJ70 and showing up. CJ7 showing up.
Now I try to read the license plate. And
1 vehicle red NTZ2JET, NT22, NTZ2JET, NTZ2JET.
now, if there are any questions, I will give the demo to go on. Well,
My first question would be, could this audio actual interference with the visual impaired people? I mean, couldn't they not hear something else because they are hearing? You meant as future work, you want to improve this part. What kind of improvements would you take?
well, for example, as you have seen, the mobile phone directly outputs like it says literally.
Oh, so it's on speaker now.
It's like a text-to-speech service.
Okay.
And my idea was that maybe we shouldn't use words or something like this, but use specific sounds, like a conventional sound, in order to be more concise.
Right, so like a click, it's a bus.
Exactly, something like this.
Are you working with actual users?
I haven't had the chance. I only developed this application as a proof of
It's
concept.
really promising, so congrats.
the idea would be that the visually impaired person would carry the phone like on a necklace. Like this can be used together with a walking cane, for example.
Yeah. Well, you can use anything.
Yeah,
basically.
it's really runs on a mobile phone, so it's up to the user how.
Between the images, you presented some signal representation. What was that?
That's just an animation. Basically, the application has an accessible live mode. That we have this. So this is the normal live functionality in which we can see the bounding boxes. But this is useless for a visually impaired person. Therefore.
But anyway, it was a silence signal, which is not for
Like
the
a sine wave, right?
Yeah.
That is
It
just.
has no meaning,
Yeah.
even for us who can see.
Yeah, it's just an animation which is played while the text-to-speech service is running. Basically, while the mobile phone talks, that thing just runs. It's just an animation.
It's misleading, because you think that there is some information in that silence, but probably it's not.
Maybe this also could be like, for example, not all visually impaired persons are fully blind, or some of them can see partially, and this can also be a point where some information could be hidden. But as it is now, it's just a simple animation. That way.
In the SCSS, would you in the future maybe detect the number of the bus? Like for example, you have two buses and see one's 25 and the other.
Technically speaking, if the phone is pointed at the bus and it can see the bus, the OCR service can run and it tells the number of the bus. In the same fashion, it told the license plate number.
Okay, so it is already implemented.
It is not perfect, but of course, one advantage is that the application and the object detectors are decoupled, meaning that any object detector that respects some minimal compatibility requirements can be plugged into the application and it runs normally. So maybe this part can also be easily improved.
I have one more. Have you considered like translating the image in kind of vibrations on like a ring or something like wearable for instead of audio, just it should vibrate in a specific way, maybe over a larger section of skin.
I don't know. This I was thinking, but no, it's very easy. But yeah, it's.
It could be because they are very sensitive
Yes.
on their touch. So
Also on the.
yeah, also. Yeah, maybe if you hear a click, so you can have like a larger scale of things, but you use both. Or
Yes.
if it clicks in a specific way and it vibrates in a specific way, it's a blue bus. Something like that. And yeah, I believe you can like give more information in a short amount of time.
Yes, that would be ideal to have as much information in it.
Yeah, because they have to be very, very fast and very, very.
Thank you.
No other questions in that case. It's my turn to present the presenter. Again, it's Bianca Ioana, integrating IoT and computer vision technologies in the process of cultivating tomatoes in a greenhouse. Is it here? Is it present? Bianca Ioana. Sorry, it's not here. We go on. Yes. So I think it's your turn because
Okay.
you're a student.
Okay. Okay. So next is Keran Yakatala. Okay. She will present conversational chatbot for medical application. Try to move it. Skip that.
Okay, so my name is Bianca, and this presentation will be about the conversational chatbot for medical application. We are going to talk about the context and motivation of choosing this particular issue, the problem statement, some theoretical aspects that we have considered. Then we will proceed with an implementation overview, the results, some future improvements, and finally a short demo of the application. For the context and motivation, it is a known fact that cardiovascular diseases are the leading cause of death globally. Despite this, most of these diseases can actually be prevented by making some lifestyle changes, such as reducing the tobacco use, having a healthy diet, and so on. Another consideration was the fact that most medical chatbots are general purpose, which means they are not tailored to a specific domain, for example, cardiology. For the problem statement, in order to address these issues, we aim to develop a chatbot that can do the following. Raise awareness of the risk of cardiovascular diseases, predict the risk of getting such a disease, providing personalized lifestyle advice for the user, and handle cardiology-related questions. The theoretical aspects that we have considered are the classification concept in machine learning, because predicting diseases can be seen as a classification task. Then we discussed about natural language processing, as a chatbot uses this for interpreting the user messages and generating a meaningful response back. After this, we have discussed about conversational user interfaces. We have analyzed the need for the chatbots, their evolution over time, and also trending implementation approaches. In the state-of-the-art section, we have shown that chatbots are being used in the medical domain more often than ever, and also there is also heart diseases are still a topic that need to be approached in this field in order to raise awareness and counseling. Okay, the technologies we have chosen for this are Python, especially for the libraries that it provides, such as SCSS, which has helped us with the classification task. Then for the chatbot, we have used the RASA open source framework, which is a trending chatbot development framework. And for the question answering system, we have used Haystack. And finally, for the front-end part, we have used Angular. Okay, here we have a picture of the architecture of the application. Here we can see the user and how he interacts with the front-end part by inputting his message. This message is then passed to the RASA component, which is processed by the NLU pipeline and then the core. And this component can also talk with the action server in order to either call the disease prediction model or the search system model. Okay, here we have a short implementation overview. For the prediction model, we have used a data set of patient data containing risk factors, which has nearly 70,000 records. And we have used an ensemble of classifiers with a hard voting classifier. This model we are going to save in order to use in the chatbot assistant. The chatbot assistant, as we have mentioned, is developed using RASA open source and implements the functionalities discussed in the problem statement. The front-end part shows the integration of the assistant with the website and contains a widget so that the user can talk with the developed assistant more easily. Finally, the front end also contains a user experience page in which we can see statistics about previous conversations. Okay, for the results, we have managed to obtain an open source application that is able to hold a conversation with the user and provide meaningful lifestyle advices for the user. Okay. For validating this, we have created a Google form which asks the user after using the application to provide some feedback about the application. Okay. For the conclusions, we have applied artificial intelligence and trending technologies for obtaining an original approach that is meant to help people prevent developing a cardiovascular disease. What we can do next to improve our solution, we can add more documents to the knowledge base so that the chatbot will provide more accurate answers. We can also add more features to the application in order to make it more complex. And finally, we could deploy the application to some popular channels like Slack or Messenger. Okay, now we will have the short demo video. Okay, here we can see the home page and the about page, which gives the user the idea of using this chatbot. Then in the chat page, we click on the prompt and the chat widget opens. Now we can talk with the assistant and we can ask a cardiology-related question, in this case, what is myocarditis? And now we need to wait for the model to process the question, transmit it to the RASA model, and wait for the search system to perform the search for the question. Okay, it has managed to retrieve the response that myocarditis is diseases affecting the muscle of the heart. And now we are going to ask the chatbot to predict our risk for developing the heart disease in the near future. Now the chatbot is going to ask us some series of questions, including risk factors. We'll ask our age, gender, height, weight, cholesterol level, and so on. And is going to process our answers and transmit these values to the prediction model, which will return the prediction we either are prone to develop heart diseases or not. Okay, and now it's going to predict, and it predicted that we are at risk of getting a cardiovascular disease. If we say yes to the prompt for giving lifestyle advice, it's going to analyze our responses and give advice based on this. Okay. This is it. Thank you. Any questions? Yes.
I have a question. Have you studied a bit about GPT-3?
Yes, about the transformer.
Yes, and have you considered giving it a more like human-like nature? Because right now it looks like a form.
Yeah.
I click this, answer this. Just a question to you if you consider this, and if how far you've come with actual testing it with real users.
Yes, okay, so for the transformer part, these answers that the chatbot gives are basically hard-coded. You can give more example and it will choose randomly one.
Okay.
It can be more personalized. This was just for the prototype, so it can be made to look more like a human. The responses are now a bit rusty. It's like asking you what is your age, what is your, but it can be more human if we added more data to it. And for the testing, I didn't manage yet to test it. I only gave it to a few colleagues and users to test it and provide some feedback in order to make some changes. But it is an aspect that is worth considering for. Thank you.
I have a question. I truly didn't understood how do you make the prediction? What is your artificial intelligence algorithm which, based on these answers, generate the prediction?
Okay.
Can you give us more details about it?
Sure. So the model was developed using the sklearn library, using the hard voting model, which is basically an ensemble of classifiers. It has 3 classifiers and it combines their prediction with the most voted prediction, let's say.
Did you have a training phase in which you gave hundreds,
Yes.
thousands of data to be trained, and after that you built up a model?
Yes, so
Because that part probably should be in your presentation. Okay. So that part is the interesting part of the whole project. Not answering, okay, it's, the usual way of giving the answers, but how do you do that part? And the other observation, probably during your career, you will do a lot of presentations. Sorry, I didn't see any words there. It's probably also my problem that
so
I
like the
cannot
font
see.
size or something.
So, one basic rule, you never use fonts less than 20 in any of your presentations. So probably all these fonts were less than 20.
Okay.
It cannot be seen. Have you seen the text? Yes and no. No, it's because it's a presentation, use your space. Write with big letters. Yes, with 24, 28, 30 font. Yes. Otherwise, you have a lot of space and you write very small. Yes. So in the audience, there may be persons who may have some problems with this part. Okay, but it's just a suggestion.
Sure. Thank you.
Thank you. Other questions?
Thank you.
Okay, thank you. Should I present the next?
Yes, then I
Okay.
think.
So I invite Michael Marcus with his paper on Romanian use classification using transformer-based models.
Okay. It's all right.
Yes.
Okay. Hello. My name is Nicolas Marcosmin, and today I will present my article named "Romanian Use Classification Using Transformer-Based Models." I will present details about text classification problems and what are the most suitable deep learning models that can solve this problem. I will continue with showing what are the related works in this field. Then I will present my experimental results and setup, and I will show also my system application that I developed. Well, today media channels are generating a lot of content, and information is expanding rapidly and continuously. As a result, it is becoming increasingly difficult to filter or group the information that is distributed to us. Therefore, automatic text classification is becoming more significant as the volume of textual data in industrial application grows. Thus, the aim of the paper is to automate the process of classifying news into topics and to test the most popular approaches. The desire is to perform the classification of news in Romanian and to finally build a mobile application to display the results of the classification. My own contribution is made by the creation of a dataset with news in Romanian and the development of a custom approach to classify news in Romanian using transformer-based models. Well, generally speaking, text categorization or text classification is a well-known NLP task that tries to give or assign labeled textual data to examples like words, documents, or paragraphs. It can be used for a variety of tasks like spam detection, question answering, news categorization, or sentiment analysis. In general, there are two types of automatic text classification techniques. The first one is called rule-based approaches. Well, these methods develop systems based on a rule-based paradigm. Simplified, these methods are created using if-else conditions that can be introduced by humans. On the other hand, machine learning methods create its own set of rules depending on the data it receives, so ML systems are easily scalable. On the other hand, considering machine learning systems, in the last years, machine learning models have received a lot of attention. For this type of approach, the two-type technique is used in most traditional machine learning models. The initial stage is to extract certain handcrafted characteristics from text, and then the features are passed into a classifier in a second stage where the prediction is made. The most important models that can apply on text classification are multinomial classifiers like naive Bayes or random forest with reduced complexity and not so great results. And the second technique is named transformer-based technique, like BERT, which is a Google-developed transformer-based machine learning approach for pre-training NLP, or XNet, which is an extension. Well, what is a transformer? Transformer is an architecture that uses two layers to change one sequence into another, and the layers are encoder and decoder. Model based on a transformer architecture uses a developing collection of mathematical approach known as self-attention, which is responsible for modeling dependencies between different parts of the sequences. So self-attention, it is like a layer. The image from the right side presents the architecture of a transformer, being first presented in a 2017 Google conference named Attention is All You Need. Regarding related work, in the last 20 years have brought many approaches in terms of text processing and application of NLP methods. Starting from recognizing small text to preparation of complex models of deep learning, different methods have been used depending on the amount of text or data that was available until now. Several papers were reviewed, papers using different methods and datasets like 20 News Group, BBC News or AG datasets, and methods like naive Bayes and different types of BERT architectures. A reference work in this area, which includes and synthesized methods from the recent years, is deep learning-based text classification comprehensive review. The paper shows excellent results regarding deep learning models and that can be observed on large data sets with tens or even hundreds of thousands of data, but few classes. An example here is AG News, which confirms the efficiency of the models when texts are well delimited into categories or topics, and learning can be done easily without overfitting. By comparison, a multi-class data set, namely 20 News Group, the results are good, but there is room for improvements. Well, as far as the Romanian language is concerned, the last few years have not brought many NLP test approaches that can be studied in Romania. However, some results were identified applied to other tests, such as name entity recognition, machine translation, or sentiment analysis, with good results. The innovative element brought in the work is the application of deep learning models on Romanian news. To achieve this, in the first instance, I created a dataset with news in Romanian. For this task, a free API client was used, namely Newscatcher API. After that, a Python script was created that retrieved all the news in the Romanian available in the last 24 hours or for a specific longer period. The total size of collected dataset is approximately 11,000 news. Well, after creating and obtaining the dataset, the process of training and fine-tuning the pre-trained neural model was performed. To obtain the fine-tuning models, our proposed approach makes the following steps. Starting with parsing dataset and loading news into memory, then applying some text cleaning methods like lowercasing, delete invalid charts, or transform the applicable marks. Then, of course, splitting data for fine-tuning in testing and training, loading pre-trained models and compatible tokenizers, converts text with represented vectors that suggest and determine relationships between words. Then we initialize the trainer and let's establish, train and test the model through the fine-tuning process. For the experiments, a Python library was used named Transformers for Hugging Face. The library provides API that lets the user to instantly download and utilize pre-trained models on any text content. Thus, for training, two specialized classes were used, trainer and training arguments. Regarding metrics, three metrics were calculated: accuracy, recall, and precision. Well, several pre-trained models have been tested trying to find the most suitable model, as the best resulting model can be used together with the mobile application that was developed. The results highlight the complexity of the links between words and the difficulty of learning and distinguishing between them. It is thus observed that fewer and better distributed topics increase the prediction accuracy quite a bit and help to better understand the predicting news that have not been seen before. Regarding the system application, I developed a mobile application that uses our approach for classifying and displaying Romanian news, but it is also working on English content. The application allows the user to select the category and the region from which he wants to get the news. The available regions are Romania, USA, or United Kingdom. As a technologies, we use Python and other specialized libraries like Hugging Face or Sklearn, and for the mobile application, we use the workflow pipeline of the mobile application is as follows. The application uses a free API called News API to bring the latest available news based on a preset parameter such as category and country. After that, the news is sent to a local API where a previously fine-tuned model is used for classification of received news. And in the final, the news with resulted topics and extracted keywords are returned to the mobile application and are displayed. In conclusions, transformer-based models are appropriate for news classification problem. The innovative aspect of the work was the application of experiments and using a data set in Romania. A future approach could be to extract more historical data and create an even more complex Romanian data set that can extrapolate and recognize topics and subtopics as well. And of course, getting better results, it depends also on the complexity and the correctness of text content. Thank you. Any questions?
I believe I'm here to ask you questions. My colleague should come next. I have several questions. So, what kind of classes are you using? So, it's classifying the news. Can you give us some more examples of what kind of?
I can go back here. Moment. For Romanian, we have starting from 50 classes, and the best result model was on a total of 6 classes like business, technology, sports, entertainment, politics, and economics. But the total amount of data set is even higher, but the other classes are not that high number of records. So I tried in the first instance to train on all classes, but the results were not that great. And then I decrease on lower number, and the final model that I used also for the mobile application is the last one that uses 6 classes.
Okay, thank you. And one more question. Have you tried deploying the application on Google Play or something like that? The second question to that question is, if I recall correctly, there are some restrictions for news aggregators. Have you encountered anything so far?
Regarding deploying, it's as a future work for me. The problem is here that, not the problem, but the limitation is that I should find a server that can, where I can deploy, starting the model, the fine-tuned model, and that can correspond and give me the results from there. And of course, on Google Play, it would not be that difficult. And regarding the news, well, in this part, I'm not getting the news. The application just shows a reference to news, and if you access the news, then you will go to the corresponding site. So I'm not actually getting, I'm just showing as an topper.
It is an aggregation, so you have like a headline and a picture.
Yeah, I'm having that. Yeah, I'm having the headline and the picture. Yeah, you should consider also finding an approach, but the main issue here will be to find a server that can use my at least two models, because I have one in English and also on
AWS.
Yeah.
Okay. Other questions? I believe if you wish, you can scroll the demo part, so my colleague can also see how the application.
I'm having the application in my phone. It's
This is like, that's fine. It's pretty
the flow pipeline application, get values from API, predict the topics using my fine-tuned model, and then show me classes and keywords.
I have one. Have you compared your results with the naive Bayesian technique? Because you said that naive Bayesian is not so good. So
I know. I also tried. I tried myself naive Bayesian. Just a second. I started with multi-class. I tried naive Bayesian and the forest, like 69-70 accuracy for my trade. Then I go with transformer-based models like BERT, XNet. The first, I begin with the English data set and English approach, and then continue with my personal with Romanian news. So I tried that, and it was not so great for my personal experience.
The naive Bayesian was not so great.
No. In this case,
Usually it's surprisingly good. Basically force short texts.
maybe at least what I find out in this case, transformer-based model that I'm using, that self-attention is more reliable because of the connection that he makes between words. So,
Okay, thank you. And the same observation, try to use.
Data bit, yeah, sure.
Okay.
Thank you.
Other questions?
Oh, sorry.
Thank you.
We go on to the next presenter, Petrian Florin Daniel. Yes. His presentation is about the automatic buffer overflow and format string vulnerability detection and exploitation. So he will show us how to be a hacker. Yes. Until he's doing his
something like that.
routine. Yes. It's a little bit intriguing, how to exploit vulnerabilities. It's a good tool, not for positive persons.
Yeah, good for white hackers.
Okay,
so my name is Petrian Florin. I'm going to show you PwnMaster, which is an automatic exploit generator, which also detects vulnerabilities. Okay, so here's the outline of the presentation. I'll go into detail in each section. First, let me get out this thing from here. Okay, nice. Okay, so as I said, PwnMaster is an automatic vulnerability exploitation system which has 4 basic components. The most important and the most work I've done is on the vulnerability scanner component, which works on Linux executables and can automatically detect vulnerabilities, which is format string buffer overflow, some of the most common vulnerabilities in ELF binaries. So for this approach, I use symbolic execution, which we'll go into detail later on how it works. Basically, it identifies the vulnerability existence first, and then finds the input to trigger that vulnerability. Nice. Okay, so the next one, which is also very complex, is the automatic exploitation generation component. This one tries to find the right tools to execute code in order to gain arbitrary code execution on the victim machine. Basically, it gives the attacker a terminal shell and can do anything they want on the remote server on which the program is hosted. It applies various techniques like read to libc, goat override, and shellcode attacks. And this one uses the Python PwnTools library, which helped me make this module. Okay. Okay, nice. So, as I said earlier, the motivation is that buffer overflow and format string vulnerabilities are very common, and anything of bugs that you have in the application that could result in arbitrary code execution is very critical to be found as fast as possible. So basically you need automatic exploit generation tools like PwnMaster in order to classify those types of bugs and fix them first before anything else. And it's also a great didactic tool for me as I implemented, I learned a lot of exploitation and about how to use symbolic execution correctly. Here are some statistics, don't know if you can see it. Basically, in 2021, out of 20,195 security vulnerabilities, 400 were buffer overflows and 401 are information leaks, which could be from a formal string vulnerability. So it's common even in these days that these vulnerabilities can be exploited. So my proposed approach is to first have a binary parser and searcher, which in my case comes with the Pontus library, in order to extract information that might be needed in the vulnerability phase or in the exploitation phase. In this case, we will go later on what kind of information we get from there. And we need a symbolic execution engine in order to aid in the detection of vulnerabilities. Also, we can have a lot of vulnerabilities in our application if the programmer is really that bad, but not all are exploitable. So we will have a filter of vulnerabilities in order to just get the critical ones and see if they can be exploited further. Okay, and we need to have, again, use the attacking exploits. We need to use various attacking methods in order to achieve arbitrary code execution. And of course, those kind of techniques have to be used depending on the vulnerability characteristics. Okay, so here is a basic architecture of PwnMaster. It's a pipeline architecture. You basically you give the program like a Linux executable, and it will give you a working exploit. We have a binary analyzer which will parse all static information from the binary, and also has a dynamic analysis part in which you start the process and see its memory while it's running. So you basically need a GDB module, one that can debug the program in order to see how the exploit is working in memory. The vulnerability detector, which as previously said, uses symbolic execution, and vulnerability filter, which will filter out any unnecessary vulnerabilities that cannot be exploited, and the exploit generator. So for the binary analyzer module, some information that needs to be extracted is the libc version, gadgets, function addresses from PLT and GOT, and most importantly, the application security mechanisms, which are PI, ACLR, Canary, Railroad, and NX. So the libc version and the gadgets are needed in various attacking exploits, like in ReadyLibc, which is the most common that will be used by PwnMaster. And the function addresses are needed in order to navigate the program and try to achieve arbitrary code execution. And the security mechanisms have to be known in order to be bypassed. So here is a sample of symbolic execution run. Here we have a function which is fun. Okay, so we have an input, we have a computation that uses the input, and then we have a comparison, a conditional branch. Basically, what symbolic execution does, it gives the input value an x, which is an arbitrary value, and then from there on, computation will be x times 2 plus 10. So basically, it will be like math. And let's say we want to arrive at the you shall pass message from there.
In order to do that, we constrain the input to arrive there. And symbolic execution will basically give an equation. Will be x times 2 plus 10 equal 30. And when we get the concrete input, x will be equal to 5. So this is how we will find input that will trigger vulnerabilities. We'll basically constrain the input to be in such a way to find that vulnerability. So for buffer overflow, we use the following approach. We basically constrain the instruction pointer register to a dummy value, and most importantly, avoid exit calls. As it can be seen earlier, there was an exit call there. So, especially for buffer overflow, we want to arrive at the end of the program in order for the return address to pop into the instruction pointer and achieve arbitrary code execution. So we want to avoid exit calls. And if the state exists, so if there is an input of all inputs of the user input that can overflow until the instruction pointer register, that means we find a buffer overflow. So that's the approach. For format string detection, which are printf, whatever, all that family of functions, we'll hook the function, and then we will analyze it while the binary is running. So if the first, not necessarily the first, but if the format specified argument is symbolic, which means is controlled by the user, basically you can see in the memory each section has some rights. So if that section has a write permission, this means it can be controlled by the user. So this means you can write to that argument. And basically that's how you detect format string detection. Another type of format string detection is if you have a lot of format specifiers, so you have %d, 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 a lot of %ds, but you have no arguments on that function. Then what you will do is you will leak all addresses from the stack from there on. So basically it will be an information leak which can use further to bypass some security vulnerabilities. So basically we have two symbol detectors which I've shown. So it's a buffer overflow detector and format string detector. But you also have some composed detectors. Basically, so the format string and buffer overflow detector will first find a format string and then a buffer overflow in the program. The next one is a format string and another format string detector, so you will find those in that order. And we'll use an intermediary state in the symbolic execution in order to find those two vulnerabilities in that specific order. We'll talk about later why this is useful. Okay, so here we have the vulnerability filter module, which is basically a table. And here I only left Pi, Canary, and Railroad because those are some of the most powerful that can make a vulnerability non-exploitable. ASLR and NX can be bypassed really easily by both buffer overflows and format strings. So I only left those that cannot be bypassed. And as you can see on the format and buffer overflow column, you can see that if you have that configuration, you can bypass all security mechanisms. So basically, you can, anything that the party could do to prevent you, they cannot do it. You can achieve arbitrary code execution. And on the rest of the columns, you can see other constraints for each vulnerability, but that one is the most important. Okay, so for the exploit generating module, basically again, we have correspondence between detector and exploiters. For the buffer overflow detection, it will give the input needed to trigger the vulnerability to the both exploiter, and the off exploiter will use a red to libc attack in order to achieve arbitrary code execution. And the format string exploiter, sorry, so there's detector, but it's actually exploiter, can be used to get arbitrary reads, arbitrary writes, information leaks, and a God override attack on the binary. So the composed exploiters are useful because basically you can use one vulnerability to cover the weakness of other vulnerability. So you can use format string in order to bypass pi, in order to bypass canary, and then you can freely use buffer overflow to do the arbitrary code execution part. Or if you have a format string and format string exploiter, you can again try to bypass the security mechanisms and then use another format string to apply a God override attack in order to achieve arbitrary code execution. Okay. So some test setup. I will present some vulnerable application, and I'll show the results of POMmaster, how he was able to execute them automatically. Those are 64-bit Linux executables, and some conditional branches were put in the program in order to simulate the program's complexity. So here is the functional test. It doesn't really, okay, kind of shows. On the first box we have a format string vulnerability. The second box we have a buffer overflow vulnerability. So we are in the FMT BOF case, the one that can bypass all security mechanisms. Here all security mechanisms are enabled, and takes POMmaster about 10 seconds to crack it. So after running this program, we get the vulnerable input from the detector. So as can be seen here, we have some if branches that you have to go through in order to get to the buffer overflow. So for example, there's magic 1. And here you can see it's magic 1, and the second input is it's FFF, that is the format string. The next input is the buffer overflow input. Right in the right, you can see it shows where the canary should be, and where the X's are is where the return address should be. So you simply replace the X's with the return address that you want the binary to execute. And after running the exploiter, we get a shell. We basically get out of the program on the target machine. And as a performance test, I try to use as many if branches as possible in order to see how good POMmaster is in finding those vulnerabilities. And with 10 conditional branches, POMmaster was able to take a minute and crack the program. So basically, for average size programs, 10 to 20 branches, they are cracked reasonably fast. But after some time, it just doesn't work anymore because there are too many states that the program needs to investigate. Okay, so here again you can see the vulnerable input that was found by POMmaster. So for each input, it was found the right configuration in order to get to the buffer overflow. Some conclusions. So POMmaster can be taken as an introduction to the automatic export generation world. It is viable for medium-sized programs, and can also be easily extended with other modules for both detection and exploitation. And as some improvements, I would like for future work to extend the POMmaster to heap-based vulnerabilities and exploitation. So for use after free, data free, things like that. And also use symbolic execution for the detection part, which combines symbolic execution with fuzzing, which will increase the performance significantly. And also cover some edge cases on some exploitation methods that are already present in the program. So that was my presentation. Thank you.
to imagine it as a product, so it would be easy for companies to use your algorithm.
Yes, so this part could be more augmented if you could also plug in the source code. So you can more easily find some vulnerabilities and then exploit them. But for now, I think it's more usable for for bad hackers, not for white hackers.
It's penetration testing.
Yeah, so for
it can be used both ways.
Yeah, so for penetration testing.
Okay, I have also a short question. You said that only works on Linux. What are the limitations which does not allow to use it for Windows, for instance?
So the only constraint is the exploitation module. The detector module can be used as cross-platform because it basically generates the program's memory and then uses and then hooks all functions with their functions, so from the symbolic execution engine. But for Windows, I think it can be extendable if you just use another exploitation methods. So, and that can be easily extendable.
Thank you.
Thank you.
No other questions? Okay, next is Via Natalia. The drug response prediction using machine learning models.
Hello, my name is and today I will present the project that I've been working on during the last months and which is about machine learning models applied to genetic data in order to predict the drug response. This is the agenda for today. I will start with a brief introduction of the subject, then present an overview of the related work. I will describe the dataset as well as the algorithms applied, and I will highlight the results. I will conclude with some observations and also suggestions for further development. I would like to start by introducing the topic. The prediction of drug response is critical for cancer patients, and it could have a huge impact on the progression of the disease. It can also contribute to the personalization of medicine, and this concept provides a wide range of benefits such as better drug selection, optimal dose and time for medicine usage, and least side effects as well. Machine learning algorithms have the opportunity to contribute in this domain because of their personalized predictions and also due to the fact that a huge amount of biomedical data is available at the moment. And glioma is the most common malignant brain tumor in adults, and its genetic profile can be used in predicting the treatment response. The results in this area could have a huge impact as a number of drugs could be tested in silico before considering them for clinical trials, and it will also contribute to the personalization of medicine by mapping genetic features to the drug efficacy. I will present some points about the related work. Extensive research has been done in the area of artificial intelligence applied to the drug response prediction, and they mainly use public large datasets, such as the Cancer Genome Atlas, the Genomic of Drug Sensitivity in Cancer, Gene Expression Omnibus, or the Cancer Cell Line Encyclopedia. Also, a wide range of algorithms have been applied, such as neural networks, lasso regression, elastic net, support vector machines, or random forests. While some of the studies focus on multiple types of cancer, there are also algorithms which have been developed specifically for a type of cancer. For glioma, as far as we know, there is no model developed, and this study aims at experimenting in this area. I will describe the datasets and the algorithms. I will start by explaining what data can be used in order to predict the drug response. These public datasets that I've been mentioning contain cancer cell lines. These cell lines are models which are widely used in cancer research, and the reason they are so useful is because they retain the most of the genetic features from the tumor samples. The omics are represented by three sources of genetic data: gene expression, genomic mutation, and DNA methylation. SMILES is a way of describing a molecule using a text string. This text string contains the atoms as well as the bonds of the molecule. Using these SMILES, we can generate molecular features of the drugs. And the IC50 value is the output in our study, and it represents the half maximal inhibitory concentration, which is a measure of the efficacy of the drug. As datasets, four datasets have been used in the study: the genomics of drug sensitivity in cancer, the cancer cell line encyclopedia, PubChem library, and cosmic cancer gene census. Regarding the models, lasso and elastic net are regression models which perform variable selection and regularization. And neural networks, the most popular machine learning models, have also been applied to this problem. A fully connected network was developed for the gene expression data in this study. The model which achieved the best performance was a hybrid neural network, consisting of a graph neural network for processing the drug information and three different subnetworks for the omics. Graph neural networks can achieve high performance when applied to graph-like data, such as in our case. And in this case, in this study, a graph convolutional network was applied. When working with graph neural networks, an issue that appears is the variable number of nodes. In order to overcome this, a uniform graph neural network was applied, as described in related work. And the idea behind this uniform graph neural network is that complementary graph is included besides the original graph, such that a constant number of features and the adjacency matrix is ensured. For the omics subnetwork, three subnetworks have been developed, one for each type of genetic data. For the genomic mutation, a convolutional neural network was developed, while for the other two fully connected networks were developed. And the hybrid architecture was chosen as a large amount of studies which use neural networks create a different subnetwork for each data type used, and this is motivated by the differences found between these data sources. And this is the pipeline of the final model. As I said before, it is a hybrid neural network which consists of a uniform graph convolutional network, as well as three subnetworks for the genomic data. The drug information and the genomic data are concatenated, and afterwards are fed into a CNN. And at the end, the IC50 prediction is the output. I will highlight the results achieved. So from the total samples, 80% were used for training and 20% for the test. These are the results for the first experiment, where only gene expression data was used. As we can see, the correlations are not very good and are not comparable to existing literature, but the root mean squared error is quite close. As improvements, we selected a subset of the genes, more specifically the genes existent in the cosmic dataset. These are the genes which were proven to be linked with cancer. And also quantum normalization was applied, as many studies did this type of normalization for the gene expression data. And the results improved a bit. We can observe that almost all the metrics are improved for all the three models, but however, the prediction power is still weak. A significant improvement was observed after adding the molecular information about the drugs. And the Pearson correlation achieved 0.8836, which is very different from the last experiment where the best value was 0.26. The model was further improved by additional omics. Another two types of omics were added besides the gene expression, namely genomic mutation and DNA methylation. And the Pearson correlation increased even more to 0.9306. Here we can see the loss and histogram of errors for the last experiment. And in the scatter plot, where the predicted and the real IC50 values are plotted, we can see that the two values are highly correlated. This table summarizes the best performance of the experiments. In the first experiments, the last saw was the one which achieved the highest PCC, which is the Pearson's correlation coefficient. However, we saw that the quantum normalization and the selection of genes improved slightly the results. As we can see, the significant difference is when drug information was included. And finally, the model was evaluated using five-fold cross-validation. The Pearson correlation coefficient was 0.9145, the Spearman's correlation coefficient 0.8631, and the root mean square error achieved 1.1830. And here is a comparison with the models from the literature. The first four models are developed for all types of cancers, while the MLCDN2 is developed specifically for breast cancer. As we can see, the proposed model outperforms the model which is cancer specific, and also for 3 out of 4 of the models developed for all cancers. Besides, it's quite close to the values of deep CBR, which is a bit higher. And I would like to present the conclusions and some suggestions for the future work. In this study, 3 models, 3 machine learning models were compared in the task of drug response prediction in glioma. We concluded that using only omics, only gene expression, a weak prediction, they do not have a very powerful prediction, even with some improvements such as quantum normalization and gene selection. However, the model improved significantly when we included the drug information. And this study proves that a model for drug response prediction specifically for glioma can obtain compelling results. And regarding future work, because the results are promising, but there is a range of approaches that can be used in order to improve them. The IC50 values could be transformed to sensitive resistant, so actual drug response, and this would transform the problem to a binary classification one. Secondly, other architectures could be used, such as model ensembles or a different kind of graph neural network, such as graph attention network. Also, the model could benefit from more data. This can be achieved either
including other types of genomic features or other data sets. And finally, an interesting experiment would be the addition of images. Because this model is developed specifically for glioma, images from the cancer imaging archive could be used because those radiological images are linked to patients which have genetic feature in the cancer genome atlas. And I would like to thank you for your attention, and if you have any questions.
I will start with the first question. So I see the paper used 4 data sets. I believe they are public.
Yes.
I'm curious if you try to contact like a clinical institution and try to work with them on a real case study. And if you have also considered doing the clinical trials, so you can actually like provide a medical tool that can be used in the future.
Yeah, I actually would have liked very much to work on real data, and I contacted someone from the University of Hatziganu, but I didn't get a response, so maybe in the future. Yeah. Thank you.
Any questions?
Thank you.
Okay, next will be Alexandra Willis. Several will be surveillance via specialized items.
Hello everyone, I'm Sebastian Gabriel and I'm here to present the cyber creative surveillance specialized articles. Looking at the table of contents, we will have a short introduction to the problem. Afterwards, we'll talk about data, data analysis, how we will use this data in the application, how we structured it, and afterwards we'll make a conclusion. First of all, specialized articles in cybersecurity are public, right? As most of the stuff on the internet is unstructured data. That means it's not usually made for scraping, and people, the writers have a certain public to which they are writing the article. So, unlike in news, any other news like political news, this type of articles are objective most of the time in order to make people interested in cybersecurity. Most of them are written for two kinds of people: those who are interested in cybersecurity and that's it, and security researchers. In the case of security researchers, indicators of compromise are quite important because they can tell when a system is compromised. You usually search for certain instances of compromise like amplifiers, shards, in your system. And if you have, if your system contains one shard, let's say shard 256, then your system has been compromised. Of course, if you're talking about the security company, they usually have some kind of database in which they actually have malware and the respective shards identified. So these events can be analyzed by experts. For example, I believe that we all heard about Log4Shell. It was a recent event in November last year. Regarding the existing work, Previously, only Twitter data has been extracted because it contains an open API. Usually make a request to Twitter to be able to extract their data and extract everything from there. Both of these are unstructured data types. But in Twitter, we don't have so many details as in an article. We don't have families, we don't have mothers, we usually just have a huge news header with some certain indices of compromise. So, we actually want to collect all this data, analyze it, and later search in case we are interested in finding out about an indicator of compromise of another family. In order to collect all this data, we have to know how to iterate to a site. Iterating to it, it's quite a difficult task. Let's say, for example, we have Google's crawler, right? What it does, it actually searches for each link referenced in a page for all the HTML text with a, link, eventually buttons. But we don't need that. We actually need something more specialized in our problem. So, if you take a look at the pages, we can actually see, we can actually categorize them. One kind of this example is Google's page. Well, when you search something on Google, if we don't find that stuff we're searching for in the first page, we usually click a button to go to the next page, right? This kind of page is called pages, as you can see in the first image in the top left. Second, this kind of page is usually a static page. We are requesting the details of the page, like the page number, in through the link via a query string, saying that we want the second page of the page. And they are static. That means we can actually get them quite easily with a simple GET request via any HTTP requests type of service. Second page is quite the opposite. It's I call it a pagination type of page, where we actually have to scroll through the page in order to get more articles, or eventually click a load more button. And all this stuff happens in our current page. That means everything is loaded dynamically. We cannot just do one GET request because of that. Every article is received by some kind of JavaScript code, which in the page requests the server to give out next articles. Why this is about a class? Because if you use a simple request algorithm, we would not be able to render that JavaScript code which does the codes for us. So in order to have to pass correctly this type of page, we need to control the web browser. And you can do this using some simple tools like Selenium. And the third and the last type of page is the category page, where I believe a good example is demand, for example. If we search for electronics, we might have the option to go for refrigerators or phones, for example. And it's in the image from the cover type, we have quite some categories which are eventually all worthy of to be spelled, right? Right, so now we know how to iterate this data. How do we collect it exactly? In order to do that, we have scrapers. They are quite some.
Can I have a suggestion? Could we move a bit faster to the background area and discuss more about your actual work on the platform? If you can.
Right, I had to be. We have a scraper which actually is hard-coded stuff which extracts everything with asks for it. For example, if you give him a tag or a class of 19, it's not scalable, but it's good for if you have less articles. The weight measurement is quite interesting. It usually maps the DOM page to an HTML3. Afterwards, it evaluates each node in order to give a value and extracts the node with the highest value. Differential scraper, it uses the principle that two different pages have have only the main content different. The second is the same, but it's not working in the real case because of ads and dynamic content, set content. And machine learning stable is based on a weight measurement, but it usually optimizes it by adding some coefficients. This is the architecture of a scraper. A scraper implements an interface, and then it has one or more calls depending if it's categories or not. When talking about data analysis, we are interested in the following fields: indicators of compromise, their context, actors, families, its categories in order to search more efficiently, and references to other articles. We also have different methods. For example, regex, which I believe everyone should be familiar with it. Natural language processing, in order to extract more details about the article by giving some context. For example, the entities are. You can search using entities for stuff like a text about Russia or Ukraine, now recent events. Or we can use this text keyword text search, but it requires a huge database in order to be efficient. When we want to get more references, this is the only part that we haven't actually touched until now. We will use the scraper with weight measurement because we don't want to rewrite a scraper for every website. So the first step is to transfer the DOM to an HTML3 for child. If we have a parent with some child in DOM 3, we will have a node with each child presenting the child in DOM 3. Evaluate each node using a function. Usually it is a heuristic function, depending on their features, and find the node with the highest difference. I found the function to be the fitness function to be dependent on the density of the word. For example, we all know articles have quite a long text, right? So what we want is a huge paragraph with a long text. Although if we would pick just all of the text, we will get as a result all the HTML page. So we have to be more particular and just extract the density. That's what nodes, words over children mean. Afterwards, if you want to get the references out of it, it has to have some children. Usually more children because we want other articles referenced, links to files. So that's what the log does. This algorithm achieved 78% efficiency. Okay, how can we use this data? Well, if you store our data in no database, we would not be able to do some interesting queries by searching in every field possible. So we will actually put everything in an Elasticsearch in order to later have some kind of mechanism to do Google search on time. For example, if I search for Bitdefender and the malware family, we'll have every article in Bitdefender reference that malware family. If you search for an index of compromise, we'll actually have every article listing that index. What that means is that is probably a real index of compromise, and that the system which contains it is compromised. We can also do some linking between indices and malware families, which is quite useful. Also, statistics. We can actually see via Kibana, which is kind of like an add-on for Elasticsearch, where we can see, for example, how many families, or which families in the last 7 days have been referenced in articles. That means they are quite popular and more systems are affected by it, and we should be careful to their indexes of compromise. So, to wrap this up, our application to extract and analyze data will be run as a daemon, where it updates and analyzes the articles and stores them in an Elasticsearch index. We will have that Kibana web application where an admin can see these statistics and be more careful when seeing them depending on the data. And we can implement some interface for our users in order to search for stuff, and thus security researchers can use our application in order to improve their work environment. In conclusion, this application offers a new way of collecting and analyzing articles. Up until now, as I said before, everything was scraped out of Twitter. Now we can actually extend all that information with open articles from different vendors which are reliable. Now, with this application, security researchers can analyze instances of compromise, can have better linkage between families, actors, and the indices of compromise. And this application does not mean to be a standard, but it wants to define a standard process of picking components by giving all these choices. Are there any questions?
some of the information, put it there, and it's much easier to follow.
I actually did, but I didn't get the response, so yeah.
But with experience, with time, it will get there. The paper looks very good, but I believe some of the information to be put in the slides.
Are there questions regarding the application or paper?
Sorry, I didn't have the chance to read the article, but I must confess I didn't understand the idea. So, what do you do?
Well, I actually just get all the information available on the internet about the articles and security articles, process it in order to store.
Why is specific for security? Why not for?
We can actually extend this to make to shops, for example.
Sorry?
We can actually extend all this to any shop or blog type or site.
So if it's finding good articles in a domain, why did you say it's especially for cyber vulnerability?
Because the process method was used, regarding cybersecurity blogs.
So you find good articles regarding.
We find every article and then process it and decide if it's good or not.
How do you know these articles are good?
Depending on the quantity of indicators of compromise. If it has many indicators of compromise, then it's a
article made for a security researcher. It may also be an article made for someone who is interested in security. That means it actually has many families, many actors mentioned in it.
Family will mean persons,
No,
and
absolutely.
family of persons, or family of vulnerability.
Family vulnerability. Usually, vulnerability has a name, and many vulnerabilities from a family if it comes from the same actor, using the same vulnerability.
Yeah, no, we're talking about the scrapers. Like, I'm somebody mentioned something about accuracy when I was thinking, or some.
Yeah, exactly. Well, I'll go back to slides. Alright, so Immigrant Scraper is actually a polygon. It works for only the site where you write code. Because you will say to give you all the views which have the class editor, for example. Right. The weight measurement scraper I'll explain a bit later. It uses usually mathematical functions and features. By using features, it's not guaranteed to work unless it's really hard-coded also, which I do not recommend. Because you want to use a weight measurement scraper to cover as many sites as possible. Differential scraper, it may work on that site, but nowadays as Google Ads are everywhere and dynamic content such as recommendations to what you did next might influence this kind of approach. And machine learning scraper is based on the weight measurement, but it also makes it a bit more accurate by calculating some coefficients.
Okay, so let's go to the next presenter, Karen Mogor Church, about how to harvest tomatoes, I think. Am I right?
Not only tomatoes, right now it's about apples and...
Apples, okay. Red fruits. Does the robot make a difference between the red
yes.
apples and red?
Yes. I have actually a demo and I can show you.
Okay. Let's see.
Slideshow, I think. Just a minute, sorry.
You can press on board and there's an option to hide it. It's like
The last one to the right.
the last one.
This one?
Yeah, and hide floating eating control.
Okay, thanks. Okay, hello everyone. I made and implemented a robot which is capable of harvesting some fruits and vegetables in ideal environments, and it is an embedded GPU-based approach. We haven't found any embedded GPU-based approach before, so that's the innovation in it. Okay, and it doesn't want to work, sorry. Okay, maybe like this. Okay. And so the contents of my work, first of all, an introduction. After this, I will speak about related work, overview of the system, system architecture and control, results, and further improvements and conclusions. Since this is a computer science conference, I will speak about the perception systems results at the results section. Okay. About introduction, more than 90% of the total calories came from agricultural products, and the United Nations, according to the United Nations projections, in the last 50 years, the population growth was from 3.85 billion to 7.95, and in the next 50 years, it is going to grow by 3 billion people. Decreasing productivity of cropland, it's a great problem right now, and we got urbanized societies. We have larger farms, and the smaller farms are almost vanished. And horticultural operations like harvesting require a large number of seasonal workers, and it's a great problem for the farmers to get workforce. And you can see right now for cropland expansion, the main method is just deforestation, and I think that it's not a good solution. So we should find more and more sustainable and alternative solutions, and agricultural robotics could be one. About the related work, I read more than 30 articles, and I included it in my article. About computer vision, the greatest challenge is changing lighting conditions, and actually the first method or approach was tried in 1968, and since then for agricultural robotics no robot has been ever successfully commercialized in harvesting, mainly because of computer vision, but not only. And I identified some convolutional neural network-based object detectors like Euro-RCN and SSD mobile. For the depth measurement, I read about RGBD cameras. For the navigations, in case of navigation, we have both outdoor and indoor navigation, and we use different approaches. And in case of mobile platforms, I identified some of them. In case of manipulation, we can say that if we have a robotic arm which has a higher degrees of freedom, it means that it is going to have better results, but on the other hand, it won't be cost efficient, and therefore specially designed and cooperative 3 degrees of freedom arms are needed. And about the end effectors, everything, the design depends absolutely on the harvested crop. And here you can see some grasping methods. Created work, we already worked with this issue, and we actually created a robot and presented it at the 31st International Conference on Computers and Education last year. But right now I use a totally different approach for the control method and for the perception, for instance, and other hardware. They use hardware, an interior sense depth camera, and the Turtlebot 3 waffle, a Jetson Nano, which is the embedded GPU, and an open manipulator X with a LiDAR. Overview of the system. As you can see, there is the RGBD camera, which is mounted directly on the robotic arm. It is called hand-in-eye configuration. We have there our gripper. We have a LiDAR, which helps us in navigation. I will speak about this a bit later. We have actually an embedded controller called OpenCR, a battery pack, and on the other side you can see the manipulator. We added a cooler because in our first trial we had a lot of problems with the embedded GPU because it didn't have enough computation power. So and most of the time it crashed because it was overheated, and therefore we added also a cooler, and we had the Jetson. Okay, and about perception system design, I tested 2 object detectors. The first one is the you only look once architecture, the Euro, and the other one is the single shot detector with the mobile net architecture. In case of the second architecture, I actually trained with transfer learning a new model. I will speak later about this. And for the Euro, I optimized the Euro's performance for the embedded GPU, increasing it by more than 200%. And in case of the RGBD camera, I used the interior sense, and it was actually really difficult to integrate with Jetson Nano because no existing solutions were, or I didn't find. And here is a presentation how the perception system actually works. You can see first the objects are detected, then after detecting it, we get that information based on the corresponding points for the detected object. Actually, I'm just looking for its central point, and I also look for the distance or the size of the object, because when I'm grasping it with the gripper, with the robotic arm, it's important not to damage the object. In case of apples, it's not so important, but in case of tomatoes, for instance, it's actually important. And then you can see the point cloud. For the navigation, I use the SLAM with G mapping, and the whole system is controlled with ROS, Robot Operating System. And there are also LiDARs, and every time when we are thinking about robotic navigations in indoor applications, you have to know that you have to take into consideration that first, a pre-mapping is necessary to have a pre-map and for the robot to know the environment, and after that, when we start actually to run it, to move it autonomously, it has to know its starting position. And about navigation, you can see here these little green dots. Those represent the laser points or laser dots emitted by the LiDAR, and with that we can actually measure the distance from other objects, and using an encoder connected to the activators, to the motors of the wheels, we can actually measure how much that did and where did the robot go from the starting position. Okay, and then about manipulation and then the factor, I already spoke about eye-in-hand configuration. We needed a 3D printed support, and we used ROS and Movit platform to calibrate it. We had a challenge here and an issue that we use ROS melodic distro. It's like you should think about, if we are thinking about ROS, that it has different versions, and for version melodic it didn't have a support from the open manipulator, and we had to integrate into ROS melodic, and for that we had to create an inverse and forward kinematic model for the robotic arm to be able to work with. Here you can see the system's architecture. Actually, in the main or in the central point, there is the local computer, the Jetson Nano, which is communicating with the remote PC, because it didn't have, or it doesn't have enough computing power to run both the navigation node, because it's a peer-to-peer communication, actually, to both run the navigation node, the arm controller, the perception node, and then some of the computations are done on the remote PC, and only some data are sent to the remote PC, and based on that, path planning and manipulator path planning is done. And there are multiple nodes which control different parts of the robot, here as you can see. And then here is a controller flow chart, but I don't want to speak about this because I will show a little demo maybe if we will have enough time, and then I can explain it. About training results for the SSD mobile net. You can see first I tried on Jetson Nano. I wanted to train it on a Jetson device because it has TensorR3, which is a framework which accelerates the Jetpack and embedded GPU's performance. And in case of Jetson Nano, it was not capable of any good result. But when I switched to a Jetson Xavier AJX, you can see that actually the results are a little bit better. For the training, and as for the results, speaking about real-time object detection, my main objective was to first have an AI or a CNN which is capable of detecting objects in greater distances, and on the other hand, to have greater performance. I speak here about the FPS when it is run, for instance, with display or headless, so it is not connected to display and it doesn't display anything, or simple means that it is not connected to the RGB camera and the the depth measurement is not done. And as you can see, in case of the YOLO, the first performances were about 0.26 frame per second, and after the optimization on the embedded GPU, I got 1.75, which is far better for a real-time application, but it's still not enough. So in case of demos, I used the SSD mobile net. Okay, and as discussion or conclusions, low-cost embedded GPUs are able to control autonomous harvesting robots if they are connected to a remote PC or maybe for their work to cloud. No harvesting robot has ever been successfully commercialized, partially because of higher costs. It is highly dependent on lighting conditions. Even in my case, when I was collecting data for training the network, I was actually taking care about having or collecting multiple images from multiple lighting conditions, but I was not able to make any breakthrough. And greenhouses and operational environments are required to be standardized, and manipulator systems along with Reaper should be designed for the harvesting of a single specific fluid to be actually efficient. And here are some demos. You can also find it on my YouTube channel, and thank you for your attention.
Can we see a demo for the harvesting robot?
First,
I'm just curious how it actually performs in.
Okay. Actually, it doesn't perform well at all. But I will show first of all. Here is just here is the object detection. It's okay. As you can see here, it detects the objects, and if it's out of the reach of the robotic arm, then it says. Actually, unfortunately, it doesn't seem well here, but it says that it's out of the reach, and it is not considered to be in that object list, which is then sent to the manipulator's controller, and which pets the plan of the manipulator, the robotic arm, to grip or to grasp the object. Then the second demo, it's about. There is a perception node. There is a perception node. Okay. Sorry. Not this one. Again. So there are two perception nodes here. Actually, the two nodes here. The perception node is started, and then it starts. It starts also the manipulator's node, and it starts to calculate the possible paths for the object, and then it grabs the apples. And as you can see, it will detect both red and green apples, not only one of them. And this is how it looked like. The problem was that I had a little robot for this project, and it's not ideal at all for harvesting applications outside. This is the second demo, and it also detects this one and it can grasp. And the third one, yesterday we tried a lot to make a good demo, because I always have some problems. So it's not a good application, or it's not a stable application, but I have some results, and I am confident that in the near future it will get far better. So first of all, we have to map. You see the operational environment with the robot. And then some points are published here, and those points are considered as the starting point, and the goal positions to which the robot is going to go after starting the application. And you can see here, there are the laser dots, and then when the robot starts, it just goes there. So it's in indoor environment, it's not in a greenhouse because I can greenhouse. Yeah, exactly. And then it goes to the first position it was preset to go, and then it starts the detection or the perception node, and that detects the apple and sends it 3D coordinates to the robotic arm. It takes a lot of time because unfortunately right now it takes a lot of time, but it can be optimized. And after that it grabs it and it takes the apple and puts it to further, and then it goes to the next position, and it goes and it goes, and at some point it arrives to it, and then when it is arrived, then we have to wait a lot to start every node. So one eternity later, it tries to grab the apple, and unfortunately, it's not a very good example of a robotic platform to harvest objects, so it didn't succeed at this time.
It doesn't like the red.
Yeah, it doesn't like the red apple, and maybe that's all. Thank you for your attention.
Can I have some observations? First, I would like to appreciate the fact that there are a number of technical challenges which has to be solved in order to provide that finally commercial harvester robot. Probably in the next 10 years we will not have something like this, but you have to start from somewhere. So I appreciate that you were concerned about mapping the surface, then recognizing the fruit, and finally to control that robotic arm to go exactly at the position recognized by the system. Okay, so I think it's a complex challenge. Probably the next generations of students will work. Okay. Now I have also a question. You were concentrated on recognizing the fruit, but in case of apples, the branches are as important as fruits, because even if you can see the fruit, you have to control the robotic arm to avoid the branches. So do you have a part which try to identify, or it's
no, it's going to be a future improvement. Actually, there are a lot of researches about this issue, how to grasp the object because of the branches and because of the collisions with the branches. And there are path planning applications, there are researchers who are working full-time on this issue, and there are good results. Not in case of apples, but in case, for instance, of tomatoes, where the branches aren't so, where the branches are much softer, and if there is a collision with the branch, then it is not damaged, not on the, for instance, not the robot, it's not damage the robot, it not damages the robot or the branch. But for case of the apples, the only possible solution right now, which I found, is that grasping from down, going bottom up, and trying to have this motion, this grasping method, harvesting method, and somehow try to just...
Probably instead of two-dimensional mapping, you would need a three-dimensional mapping of the...
Exactly.
Yes.
Yeah, and that's a complex issue.
Yes. Anyway, thank you very much. Any other questions about other fruits, for instance, not just apples? If not, thank you very much.
Okay, I believe next will be Christian with crypto advisor, web application for sponsor health exchange, cryptocurrency, arbitrage opportunities. Yes. It's a long day. It's a long day. Please go ahead. Okay. Is it needed, or do you have some kind of presentation?
I have a presentation.
Okay, you can just stop if you have a USB. We just need to start the Zoom. So actually, if you want to connect your own, you just have to open that URL on the Blackboard.
Oh, so
Clipboard, start, share your screen, and you're good to go.
it's easier.
Yeah, but I'm not sure if do you have a VGA cable for the projector?
No, only.
Does it have an HDMI somewhere?
Only HDMI, I think.
Then maybe it's better to just start with this.
Oh, okay. Should I send it or how should I copy it?
Sorry, can you repeat? Do you have a USB stick or something? Or
I don't think so.
just put it on a stick.
I can
Okay, any other way? Maybe you spaced it in properly. I'll try to get
Make a lecture.
Yeah.
This thing.
Ah, okay.
So 2-minute break. I get another cup of coffee.
Can you stop?
Yes.
Okay, so hello, my name is Robert Gonzo. So my paper is Crypto Advisor, a web application for supporting cross-exchange cryptocurrency arbitrage opportunities. Okay. So this is the outline. We'll start with a brief introduction. Okay, so the subject of our paper revolves around cryptocurrencies and trading automation, and more precisely, as the title implies, on a low-risk strategy called cross-exchange arbitrage. So the main objective was to develop a production-ready tool that is useful for developers and also for professional traders. Okay, so our interest in this subject stems from the fact that cryptocurrencies are very modern, continuously evolving, and have been adopted by a wide variety of organizations. So automation in the field of cross-exchange is quite underdeveloped, so that's why we thought it should be more explored. Okay, as far as originality, there are other various crypto solutions that provide information about markets and prices, but we have not been able to discover one that delivers all the factors of an arbitrage trade. Okay. So first, what is arbitrage, cross-exchange arbitrage trading? So to put it in simple terms, This approach capitalizes on market inefficiencies by buying and selling on two distinct exchanges in order to accumulate profits. Okay, so we think this strategy is low risk because here we don't need to rely on predicative markets like predictions or assess market sentiments. We just we know at the start the fixed profit and we can calculate it. Okay, so there are a lot of factors that we need to take into consideration. So one of the factors are the fees. So these are the costs incurred when trading, timing, obviously, and network availability. Sometimes exchanges sometimes exchanges may restrict the withdrawal and deposit of certain assets, so that needs to be taken. Okay, and let's take a concrete example. So let's say we have exchange A and exchange B, so we trade on the pair BTC USDT. Okay, so we must assume that we have a certain amount of USDT in our account. So we start by buying BTC with the USDT we have and effectively converting it. After that, we can withdraw the BTC by checking also the deposit and the withdrawal chains, and so essentially withdraw the BTC to another exchange where we can sell it for a higher price. So it's pretty simple. That results in profits, and you can cycle back and redo the arbitrage trade. As far as profitability, this is a formula that is based on it's percentage based on the initial quantity. Okay, so now our application is Crypto Advisor. It's a web application for spotting these kind of opportunities. So the primary purpose of this application was to provide a robust API solution, highly specialized in cross-exchange arbitrage. So we also developed a WebSocket that continuously streams these opportunities. Also, we have implemented an authentication service, a table with opportunities, complex filters, a history table with past opportunities, email notifications, and an in-browser API endpoint testing. Okay, as far as technologies, we have used Python as the main programming language, Fast API as the web framework for developing it, and Heroku is a platform as a service provider, mainly a cloud provider where our application is hosted, and a PostgreSQL database. And as client side, we have used a components-based framework Vue.js with Netlify as the client side of the cloud provider and Bootstrap for SCSS. Our architecture looks something like this. So we can see that essentially any device with a browser can access our client-side service through HTTPS. And then our service communicates with the Heroku deployed REST API that also has two add-ons, an AWS Postgre database and a Mailgun SMTP server. And we can see our application is split into multiple layers. So starting with the business layer pipeline. So this is where the actual logic happens, and this kind of works like independent application. So first, data collecting. So here we use the C60 library, which is an excellent ecosystem that unifies the APIs of numerous exchanges. So we'll integrate to use like 10 or 15 different APIs to get our data. And also here we do error handling. Okay, web scraping. Here we use Beautiful Soup to scrape fees and available chains and stuff related to that from the CoinMarket fees website. After that, the raw data is parsed in a JSON-style dictionary. So we have exchanges embedded in coins, embedded in fees, and so on. Okay, and the most interesting part, the arbitrage spotting, is made with a predetermined threshold, and then the data is sent to the REST controller. Okay, so our web layers, so here mainly user router is used for operations on the user, authentication for the login, mail for a newsletter, and lastly the arbitrage router is to communicate with the business world. Okay, persistence layer, here we have the database connection, the ORM models, and here in the repository we have the implementations of the endpoints. And lastly, because our application is hosted on the web, we have invested a great deal of work ensuring that it has a solid security foundation. So we have authentication with, we have role-based authentication, JWT, we have middleware, and also TLS, which ensures the HTTPS, and DDoS monitoring, which is provided by the cloud providers. Okay. So difficulties. So at first we wanted to design an automated system that would do all the trades on our behalf, but this was not possible as testing needed to be done with real money and it was quite difficult. But it can be done for sure. And we also wanted to implement another type of bot, let's say, that was based on statistic and technical analysis, and we have implemented a part of it, but it was abandoned. And finding the right data collector was pretty hard, as this once again proves that there aren't so many good API solutions in the crypto world, because they are usually very expensive, like enterprise solutions with like simple stuff related to prices require enterprise solutions ranging from $200 to $500 a month, so it was very expensive. So we didn't use that after all. And a WebSocket, and we assured asynchronicity between all the endpoints, so everything can work independently. Okay. So now I will show application showcase, or better, I should let it. I should show it at the end. I'll go to conclusion and then we will. Okay, so here we have a comparison to see other similar solutions. So our solution is Crypto Advisor. So we can see it does pretty okay with other existing solutions. So we can see that only Crypto Hopper has a public API, but it doesn't really deliver opportunities. It's just related to account stuff. And the number of supported exchanges, you're a bit on the low side, but it can be extended. And yes, latency is 5 minutes, like maximum. Okay, so the purpose of this paper was to assess how good the cross-exchange strategy is and if it's viable. And we think we developed a powerful solution. In the future, we want to improve our algorithm to optimize it with cost-based path-finding algorithms like Dijkstra's algorithm and stuff like that. And also we want to add other exchanges and coins and more advanced arbitrage trading methods like statistics arbitrage, triangular arbitrage. And in the end, we want to fully automate it. Okay.
You can show them that.
Okay. So it's on the web, so I need the URL because I don't remember it. It's not indexed, so I need to type the full URL to get to it.
You can hide the...
Yes. Okay, so this is how our solution looks. So here we can go to arbitrage opportunities. Here we have the table with all the current arbitrage opportunities. So Here we can also make filters on them and stuff like that. How much, like let's say, greater than, I don't know.
Can I ask you?
Yes.
Yeah, so your system gives an answer to buy or not to buy a currency?
Yes, so it's kind of like
Advice.
yes, like an advice.
Okay, so probably the best answer would be don't buy cryptocurrencies, you know. But anyway, it's my personal opinion. But why is just for cryptocurrencies? Why not for any currency?
It should work for anything because, like, I don't know, like for example, other pairs like euro.
Yes.
So it should
not
work.
for
I didn't manage to do it, so I want to expand it also on the stocks trading.
It's something very specific with cryptocurrencies,
Yes, at the moment.
or it can be used for any.
It can be. So arbitrage is made between everything. So also on fiat currencies like
Maybe, I
euro.
don't know, the frequency of changes in the cryptocurrency is very different from other currencies.
Yes,
For instance, the euro in the last 2 years never changed, just with very small amount of. So it's useless to buy and sell euro.
Perhaps the crypto is much more volatile.
Yeah.
So if you have access to information, you can see a difference in price changing between different exchanges.
Yes.
And you can buy where it's cheaper and sell it where it's more expensive. So it
Now,
might be a benefit.
in order to make a prediction, to buy or not to buy, do you take into consideration the biggest evolution of the currency, or what kind of algorithms are you using to make a prediction?
So it's nothing. This strategy is neutral from the market. It doesn't matter if it's up or if it's down. Like there are market inefficiencies, like when you have brokers, like stock trading, for example. So you have an exchange which sells Bitcoin for $1, let's say. And another exchange sells for $1.30 because it's in other state or something. And you can profit between those stuff. Like you buy on one part and sell on the other part. And that's the idea, to find all these kind of opportunities.
So you buy and sell based on
yes.
I have one more question.
Yes.
First, did you actually try and make a profit on something that you found during your research?
Yes, but I missed it. Like you need to be
very fast.
Very fast. So that's why it should be used like this, like an API stuff, and extend it. So I tried to do it, and I moved the money to the second exchange, and it disappeared when I moved it. So it was all close. It's like takes 10-20 minutes. So it's we don't have a lot of time. So here you can test it, like it should be used like this because of an API. So here, for example, if we put something.
Okay, and while you write that, another question is the actual scraping allowed in the terms and conditions of the exchanges? Because some of them did not allow that, and it's like a gray area if you can just pull the data for something like this.
Yes, I thought about that, but it's not really an exchange where I'm scraping it. It's just a simple website with fees. So
okay, so it's already an aggregator fees, right?
Yes.
Ah, okay.
So it's on the website only for showing fees. So they don't have an API, so that's why I scraped it. Okay, so something like this. If you want to test it like an API, we can get all the opportunities here, and we can see like the first exchange, the second, the coin, and the difference. So for example, here it's the difference between, I don't know if it's visible, like 30%. It's a lot. So on the first exchange, you can see the coin bond has 2.64, and on the second 3.4. So it's the same coin but different price. So that's the idea, to make profit of those inefficiencies.
Okay, so you don't try to predict the evolution in the
Thank you.
And next we have Ilana John, a framework for fine-tuning the algorithm parameters.
Hello everyone, my name is Ada Chan and I'm from Babel University. I want to present you a framework for fine-tuning algorithm parameters. The agenda for today starts by conjuring the motivation of the subject. The second part briefly goes to some related solutions on the topic, and then I will present my own solution, and as the last part, I will show you some final conclusions and my ideas for further improvement. Parameters are used by many algorithms, and it can be stated there is a strong connection between them and the performance of the algorithm. Let's take an example of an algorithm that detects obstacles on the road, and here is the output. With the green we see the output, the detection, and with the pink we have a ground truth class named obstacles. And we can see we have a reasonable output. Some of the cars were detected. But in this second output, we have better detections because also the cars in the center were detected. But in the third output is worse because we have barely some detections on the cars. All these three outputs were obtained only by changing the parameters of the algorithm. And this was a little proof that fine-tuning the parameters is a necessary step for increasing the performance. There are some related solutions, starting from a small algorithm, a restrictive algorithm that allows only 5 parameters, up to solutions based on design of experiments approach or on fine-tuning strategies. The solution evolved up until a combination between statistics and AI methods like the HORA algorithm, which is an heuristic-oriented racing algorithm. My solution is a framework for fine-tuning parameters that aims to improve the performance of classical algorithms. It was designed by combining gradient descent as optimization algorithm and machine learning techniques. I have also proposed an approximation of the derivative for non-differentiable functions. To obtain the objectives of the framework, we must increase the performance, and this is done by having a good quantity of good results, a total coverage of both the usual scenarios and edge cases, and a high quality of the output, meaning that the output is precise. And for achieving this, the framework must reduce the missed cases, and this is done by persisting the good results we already have, by covering the edge cases that are currently missed, and by reducing the false results and minimizing the errors. As architecture, my framework has 6 components written in Python. The data loader manages the interaction with the data set. The parameters are stored inside the prioritization graph. The performance of the target algorithm is measured through the evaluation matrix component. And with the help of the visu component, I can show you the output and the ground truth on the same plot for analysis using the matplotlib library.
All the results of the fine-tuning are stored in a local MySQL database by the database manager component, and the core component fine-tune params performs the fine-tuning with gradient descent, and it has instances to all these other components. And I want to mention that some of the components, like the database manager, the view, and the evaluation metrics, were designed based on some interfaces to allow an easy change of the target algorithm. I have tested the framework on a case study, which is a column-based segmentation algorithm. Its goal is to detect obstacles on the road and to create a strong limitation on the road on each side. It takes as input as a depth map, as we can see in the first image, and it classifies the data in order to detect the obstacles through a collection of pixels, as we can see in the second image. There are parameters whose values must lie in a fixed range, like positive values only, and even some parameters depend on the values of other parameters. And to consider all these restrictions, I have implemented an acyclic directed graph modeling parameters as nodes and dependencies as arcs. The order of fine-tuning is determined by assigning a priority number to each node, while traversing the graph in a breadth-first search manner. A dependency is formed by a master node and slave node, which are connected through an arc with an operator, a relational operator assigned, which states the dependencies between the two parameters. And for generic use, the graph is created based on an input file. The assignment of the priority starts always with the isolated nodes, which have priority 0, and then we start with the random node and go to the neighbors, but we must consider these connections, this connection from P2 to P3. So we have to go to P2 first, then to P3, then to P4, and have a unique priority number for each node. The fine-tuning process was based on mini-batch gradient descent, which requires a differentiable objective function, because the classical algorithms don't obey this property. The approximation of the derivative uses a step for each parameter and a scaling integer interval for ensuring the same precision for each parameter. As we can see, the formula uses the previous value, to which it adds the scale plus times the step to achieve the new value. As in the real gradient descent, the steps are decreased, but this is done only when in the last two epochs we have no improvement in the evaluation methods. So by taking one parameter at a time, we vary independently, and this is like forming the equivalent of a partial derivative. All the partial derivatives are aggregated together while we traverse the set of parameters. And this approach is combined with machine learning by using multiple epochs and batches for the data set. As for the evaluation part, I have used the ground truth. Blue means road class, pink means obstacle, and yellow is the background class, and the output in the second image. And comparing these frames pixel-wise, I have generated the confusion matrix. We are most interested in the true positives, which means pixels over the obstacle class, the green ones, and the red ones are the false positives, which means pixels over the road class. Based on these values, the precision recall and F-score are computed, but only the F-score drives the search of the gradient descent. I have conducted a special analysis to validate the idea with gradient descent using brute force. And from the matrix, we can see that it's a zero difference between the solution with gradient descent and the solution with brute force. But when comparing the outputs, we can see two differences. It seems that the gradient descent has less false positives in the rectangles with 1, and a sparser part with true positives in the rectangles with 2. This is compared with the brute force output. Next, 3 representative tests were conducted. The first one means fine-tuning with 50 epochs using an F-score with beta 0.2 and batches of 16 frames. For the second test, we only changed the F-score to use a beta 0.4. And in the third test, the parameters were split into sets. After fine-tuning the first set, those values were set, and then we fine-tuned the other ones. I have looked at the precision, the recall, the F-score, but also at the visual output on different frames. And in the default part, we can see a good quality and quantity of the detections in the day frame, the above one, and a lot of false positives in the night frame. But those false positives reduced significantly in the first test, and also the true positive persisted in 81.2%, and a slight decrease in the F-score happened for the day. In the second test, we have a good quality of the results for the day frame, a lot of detections, and for the night frame, the metrics remain slightly the same compared with the default, but with fewer false positives. And in the third case, the results are promising because we have fewer false positives in the night frame, and the F-score was better. As for the day frame, the detections are sparser, but if you compare the F-score with the default one, it's a very slight decrease. All the 3 tests were validated on a validation set, and considering that the aim was to reduce the false positives and also to increase the true positive, the second test performed the best because all the metrics are greater than the default ones. As some conclusions, we can see that a 3.6% increase in the F-score happened after a consistent period of testing, and also the scientific field gained a generic framework based on interfaces and configurable hyperparameters to allow an easy change of the target algorithm to be fine-tuned. And as further improvements, there are 3 ideas. The first one would be to use a ground truth that also considers, in our case, buildings as part of the obstacle class, because now the buildings are mostly in the background class and the algorithm also detects buildings. So basically they are discarded now. The second idea was to use more than one metric, or a metric that has a minimal trade-off between the reduction of false positives and the enhancement of true positives. And a more complex improvement would be to use a decision tree on the input data and to create some categories based on characteristics of the input data. And like we see in the picture, that's the architecture of, or the structure of the tree. And a separate fine-tuning process will start for each leaf node of the tree, basically with a different subset of the input data. Thank you for your attention, and if there are any questions.
First, the title intrigued me because it's fine-tuning of any algorithm in the world, which is not true, probably, because all the examples are in image processing, in recognizing
yes, because the case study was a computer vision algorithm.
So probably for the future, the title should reflect that you make fine-tuning in the field of image processing or algorithms for image processing, or even narrower for image segmentation in autonomous driving, because otherwise we could understand many other things.
Yes, but let's try to design the framework as to suit different algorithms. Like I also consider the case when we don't have visual outputs, like we have to compare simple values. So these are the
Okay, I know the problem because one of my doctoral students is doing something like this, but he tried to fine-tune, first to select the best algorithm for a given problem, for a general problem, and then to fine-tune the parameters of the classifier algorithms. But still there is a narrow definition of classifiers or something like this, because just to tell that for any algorithm you find the best parameters, it's a little bit strong. But anyway, I appreciate your work, and I think it's very important because otherwise the users would have to work days,
manually
weeks to find the best tuning for a given problem. Yes, so finding in an automatic way the best solution probably is a good idea.
Thank you. Thank you for the feedback.
I also have a question. So do you plan on making this like an open to use platform, like Azure, OpenML, because it's quite similar, or not in the future?
I didn't think of such an idea. It could be possible, but I'm not considering it nowadays. Maybe in the future it will be further.
Yes, like the only issues would be like hardware resources, but if you manage to get funding or to the research project, you might be able to secure that.
Yeah, sure. Thank you.
Other questions?
No other questions? In that case, we go on to Maria Larissa Radu, the robot and teacher for American Sign Language. Aero condizionato, chiaro, Ce immagina il nostro?
Nu, e de pe laptopul ăsta, acum le copiez de pe laptopul meu pe un stick. Sau pot să iau direct un cablu HDMI, pot să folosesc ăsta?
Dacă poți copia e mai safe, ca să nu riscăm să
Ok. Ia, sigur că pot copia.
Ok, așteptăm 2 minute, respirăm.
Timp mai jucăm cu aer condiționat. Dar totuși nu am oprit. Dacă te bombardează pe moment, oprit.
I will talk today about Aslira, the robot hand teacher for American Sign Language. The presentation is structured as it follows. I will first talk about introduction, then related works, conceptual design, solution description, qualitative analysis, limitations and future work, and conclusions. In this world, there are over 5% people that suffer from hearing impairments. And when these hearing impairments are considered severe, they can't hear when people are talking or anything. So they need a new way of communicating with other people. And that's how the sign language was born. In the world, there are over 200 different sign languages. And today we'll focus on American Sign Language, which has an alphabet that every letter in the American alphabet has a corresponding sign in the American Sign Language, and also the digits. For this problem, we propose a solution named Aslira. Aslira stands for American Sign Language Interpreter and Robot Assistant. That is a robotic hand teacher that can interpret sign language from spoken text or in text. And it also presents a framework for learning American Sign Language with lessons module or testing for evaluating the knowledge. As for related work, there are several robotic hands that are similar and work for similar purposes, like Sidebot or Deo. Conceptual design. First, we have the hardware components. For the finger movement, we need servo motors. To control the servo motors, we need a microcontroller. I use Arduino as a microcontroller. Then we have a UART module for sending data from the computer to the microcontroller, and power source because the Arduino is not powerful enough to power the servo motors I used. And as for the mechanical design of the hand, I used an open source website named InMove, where there are the components of the hand that can be downloaded and 3D printed and then assembled. This hand is a part of a bigger project of a human-sized robot. Okay. Here we have some pictures. In the first picture, you can see that the servo motors are placed in the forearm, right here. The second picture contains the other bigger components. This hand has around 70 components that need to be glued or we can see the components of the hand, and in the last picture it can be seen that from the hand there are several fishing threads right here. These fishing threads go through fingers and are tied to the wheels right here at the servo motors for the movement. Solution description. We have a GUI application that can work in 3 modes. The first mode is the speech recognition module. So we can speak when we start the speech recognition module, and the hand interprets the spoken words. I used a function from the Azure Microsoft for transforming speech to text. We have also a lesson module where we have 5 lessons that contain about 6 letters every lesson, between 5 and 7, 4 digits. For learning, we can see on the user interface the letters, and we can see the letters also represented on the hand. We also have a test module where we can test our knowledge by visualizing on the hand letters or words and testing if we understand correctly the transmitted word. From all these 3 modules, via URLT module, the characters or the data is sent to the microcontroller that commands the servo motors, resulting in interpreting American Sign Language. Here we have a visual representation of a letter. I chose L. We have 6 servo motors, 5 for every finger and 1 for the wrist. And here we can see the positions of every servo motor, the value for the letter L. Then we have qualitative analysis. I will first talk about accuracy and error rate. The accuracy of the robotic hand movement is 100% because it is a deterministic system. The values of the servo motors are hard-coded. It can go wrong. But what can go wrong is the speech recognition, because it's not perfect. We have a word error rate for the module provided by Microsoft Azure that is calculated through this formula where we use the inserted words that were not spoken, the deleted words that were spoken, and not seen in text, the substituted words, and the number of attempts. Also for results, we have in the GUI results module where we can see the tested words or letters we tried, and we can see a table with letters or words or a letter chart. For example, right here is a letter chart after rightly placing the words, a few words in the application. As for the limitations, the hand is not capable of performing abduction and adduction, which is like this for these fingers. And for letter K, L, and V, we need that. Another limitation is that the wrist only moves around or rotates around the y-axis like this, but we also need to point with it for the letters P and Q, and we can do that. For the representation, I used a little rotation instead of pointing. And for future work, we can train the model provided by Microsoft Azure to be less sensitive to noise. In conclusion, as later the system presented, presents a way of interpreting American Sign Language using speech recognition, visual way of learning, and an effective way of testing.
Thank you very much. I have a comment, question. I think in most of the sign languages, you represent words, not letters.
Yes, for the system we use finger spelling, which is a technique where every letter has a correspondent and we spell it on letters.
Yeah. Usually when there is no sign for a very specific word.
Yes, there are signs for words or greetings or even sentences, very common sentences, but I use here finger spelling.
It's just for letters.
Yes, the future.
And is there a difference between Romanian and English letters?
Yes.
I know some, but
There is a difference between every language. There are similarities and differences.
for instance, do we have for a special sign
No.
or for or letters which are very specific for the Romanian language? Or did you analyze?
No, I don't even know the Romanian one, but I think we have signs for joy. And I have prepared a video.
And another question: how fast can we spell a word?
As fast as we want, because the seromotor, as fast as we can read them. The seromotor works, but too fast and we won't understand.
So it's a question of the man reading the signs, not the hardware making the movements. Because sometimes, between two letters, maybe you show a third one.
Yes.
You must have some transition between two letters. But anyway, other questions? After each letter, it comes into a rest position, or
yes,
you just make the transition?
The rest position is very fast and we can see that. But for the transition, because some letters are like this and some like this, and if you want to walk on and move, it's better to be in this position. Here you have the GUI application. Hello. It's a little delayed, I'm sorry. Here is the speech recognition module. You can see there. I don't know why it's delayed. Here is the GUI. This is a picture of the letters of the American Sign Language. Here we enter the loading mode. We can see here is the letter represented on the hand. We have a slow mode or a fast mode. It's a few seconds faster. We can repeat the lesson after we finish it. We have multiple lessons. Testing mode. This mode where the hand represents something and we have to guess what it is. If we guess right, we get a message here. Here I enter something wrong to see we have a percent of right guessed. Here we have in the hard test a full word represented, chosen random from a list of 10,000 from MIT. Again, I wrote something wrong, so we can see that.
Other questions, because we have to go on.
Okay.
Unfortunately. Thank you very much again. A colleague will present next.
Next, we have portrait-based approach for exposing deepfakes by identifying facial portraits and videos.
Yeah.
My name is Cristian Borbi, and today I will show you my take on the domain of deepfake detection. The title of my work is A Frame-Based Approach for Exposing Deepfakes by Identifying Facial Forgeries in Videos. Now, breaking down this title, it's a frame-based approach, meaning that I will take input videos frame by frame and process them. And identify facial forgeries means that only the facial area will be considered when exposing these videos. Now, the first question, maybe you all know the answer to, is what is a deepfake? And it's a term with unclear roots because many sources show different things, but the meaning is quite suggestive, which is defined as manipulated videos using deep learning techniques. Well, the importance of detecting such videos is evident. This kind of videos can be a threat affecting not only public figures, but only ordinary people. These forms of falsification create a huge threat to violation of privacy and identity and affect many aspects of human life in general. The agenda for today will be like this. First, I will go on a brief description of deepfake creation methods because it's important for detecting to also acknowledge the methods of creation. I will then move on to deepfake detection, domain definition, and overall description. Then some implementation overview and details, elements of novelty, experiments, experimental results, conclusions for future work, and some bibliography. Okay, about deepfake detection very briefly. More details on this is on the paper, but here I will present very short that first by pointing out that facing the reality, deepfakes are quite easy to create, and there's a lot of applications that do this thing. And the two most popular methods for creating deepfakes are by using the autoencoder-decoder structure and generative adversarial networks. For the purpose of this work, I consider the database using 4 deepfake generating techniques, which are deepfake, face swap, face-to-face, and neural textures. Well, for the first two, deepfake and face swap perform facial replacement, which is meaning that it replaces the whole face of a target to the source. Then I will move on to face-to-face and neural textures, which is facial reenactment. And I give the definition here is an emerging conditional face synthesis task that aims at fulfilling two goals simultaneously. First, to transfer a source face shape to a target, and while preserve the appearance and the identity of the target face. Well, facial reenactment is harder to detect because most of the time it only replaces some mouth area to fake speeches, for example. Okay, and in terms of detection, is normally considered a binary classification problem, but I will show you another approach as future work, which considers temporal features across frames. And it's divided into fake image detection and fake video detection. Fake image detection can refer also to detected fake images created by Photoshop, for example, not necessarily deep learning. And fake video detection most of the time falls into the category of multiple face image detections because videos are taken frame by frame and then processed as images. The implementation overview, sorry for the alignment. First of all, the face detection and extraction take the face forensic data set, and more on this data set I will show later. Extract face frames and store them labeled as real or fake. Then perform the classification using a mesonet-like architecture, but trying to bring some improvements to it, using this collected data set. Then have a back-end inference module, which is a Flask application, and a front-end mobile application to make a bit more practical. The dataset and data acquisition part. Here I have an image representing the workflow. So I have a collection of videos initially, and take these videos frame by frame, split them by frame, and perform a face extraction on each frame. And then I obtain a new dataset of faces, where I have about 2 million faces, and train them using convolutional neural networks to get the output of real or fake. Now there in the middle you can see something about reenactment and replacement, which are the techniques I talked about earlier. Face extraction is pretty much a solved task, so I use the pre-trained model, the OpenCV face detection based on single-shot detector, and this was used in two parts. First for collecting my dataset, and the second for the inference module when you give the input video and take the faces out of it and perform the classification. There is some sample extraction from my dataset. Okay, then for the real fake classification, I have this architecture. Mesonet is the backbone of my work, and it takes the input images of 256 by 256 colored images, passes them to 4 convolutional layers with batch normalization, real activation function, and then at the end we will have 1024 features within a dense layer fully connected. After that, a hidden layer of 16 features, and on the last layer is a single feature because this is a binary classification, and it will yield a binary result. The elements of novelty that I brought is first it would be that using a combination of 4 data sets and merging them into a single one. So the phase forensic data set I used it's more like for the benchmarking purpose created, and it compares real frames with fake frames connected by deepfake, by face swap, by face-to-face, by neural textures. And I will merge this into a single directory labeled as fake. And of course there will be some class unbalance, but I will solve it by class weighting, as I will show later. Then I will wrap all this theoretical work and the approaches over the phase forensics dataset in a mobile application, and it will be more used in real-world scenarios. And I will try to collect also faces using an enlarged bounding box, and the motivation behind that is that many times we can observe a double chain when overlapping faces, and by enlarging the bounding boxes for faces, you can spot these mistakes or spot forgeries in hair, which is a very complex thing to create, and it might help. But I will show the experiments on this later. Okay, so about the experiments, the goal of them was to achieve better performance than the plain Mesonet architecture. They are presented in the following, but I have to mention that for the experiments I used the sample data set, a smaller one, using 300,000 images for the training part, and 1,200 images for test, 12,000 images for test and for validation. Okay. The test is very important to know that the test and validation part are balanced, because in real world scenarios you can know exactly what the input will be, so just the training part will be unbalanced because that's how the data set was collected. Good. First experiment was training the model with class weighting to solve the unbalanced data set problem. Well, most of the time on class unbalance on 1 to 3.5, it's not really a necessarily problem in deep learning, but at this level when data is very similar to each other, it's very important to do this, because otherwise we can observe that it predicts true real images as fake many times. So the accuracy was improved to 77% from 62% after performing class weighting, which is a huge improvement. Then I tried that in large face that data set that I talked about earlier, but we can see that it did not perform better than the classic data set, because many times there are background noises caught in this enlarged area, and that made my model perform a bit worse when using the enlarged faces, so I stick to the classic face instructions. Okay, then I also tried some experiments related to data augmentation and to modify a bit the architecture, but did not yield better results. So my final model is the one trained on 2 million images belonging to 2 classes real and fake. The training accuracy achieved was of 85%, and the test accuracy of 83% with quite good metrics in precision, recall, and F1 score. And we can see that it's balanced because the true positive and true negative rates are quite similar. Okay, I have here a practical usage. I hope I can. Yeah, this is a deepfake from March with Ukrainian president, and it's quite good. I mean, if you don't pay attention and you scroll in social media, it can fool you. So I try to run inference on this for the example. This is how it looks.
I mean, you can observe some shimmering and some brightness fluctuations, but it's not a bad attempt. So my application looks like this. I have a front end. The design was not the purpose of the work, but you can use deepfake video check and deepfake frame check. The frame check is basically just the video check is many frame checks, so I only will show this one on the video. And it takes about 10 seconds for this video, so videos 10 seconds, and I will show results in number of frames, how many of them were spotted as fake and as real. So we can see that it's a 76% 76% of fake probabilities in 112 frames, and all of them had faces, and the final estimation is fake, which is correct. Okay, then these are some more experimental results. First are some poor quality deepfakes, which are easily spottable by human eye, and it recognizes them as 100% fake. Then some medium quality deepfakes. These are done by facial reenactment. We can observe on the teeth area that there are some forgeries, but these are also recognized as fake. And then I use the CelebDF dataset, which I don't know what the method used, but we can see that it's correctly predicting them as fake too. So this model can be used for more than the 4 creation methods I mentioned earlier. But then some experimental results on viral deepfakes and on real videos. The first one is on deepfake with President Obama, which has 9 million views on YouTube. The second is the one I showed you earlier, and the third one is another Obama deepfake. And then some real videos, because it's important to recognize reals. But you can see in the third that is recognized as fake, but this is also a problem of the face detector, because it only extracted 39 frames face frames out of the 146, and it has a problem, the face extraction, with this hair intervention in the faces. Okay, and some conclusions for future work. The nature of deepfake technology was presented and considered. The development of this domain is obviously not closed, but it's safe to say that the reasoning behind the purpose of this work was the motivating factor in its development. And as future work, we can try to feed the input of the sequences to the classifier, because many times these deepfakes are very, very well created, and it's hard to spot them by single frames. And if you watch some movement, it's easier to spot deepfakes. So that would be one improvement that can be done in the future. And another attempt can be stacking together images on top of each other, using 9, for example, for 3 images, 9 color channels. But this must be experimented and see if it brings any improvement. And this is the bibliography.
This will become like the cat and the mouse game, because this tool can actually be used as a test for a better deepfake algorithm, right?
Yeah.
So you can just keep trying until it passes.
And that's a problem, because the first step is taken by the creation method, and it's hard to detect, to create a good classifier for detection.
I wish you luck. Questions?
Yes, just an observation. One of my doctoral students tried to collect incriminating documents regarding, I don't know, criminals, or his job is related to that. And because of these techniques, it's very hard to demonstrate that a given document is about that person or not. Tools like this are very important to make the difference between a true video or a fake one. I appreciate it.
Thank you very much.
Next, I may suggest you to see if an exam is fake or not. Yes, to see if the results presented by a student is is true knowledge or a fake one.
That would be a good idea.
Any other questions? No other questions? In that case, we go on to the last but not least presentation. Motora of the European combined application for genetic programming and deep learning for detecting fraudulent transactions. Okay, floor is yours. Until he is doing his job, I should mention that after this presentation, we have to go to room number H11. There will be the closing event for this conference. So after a short break, I invite all of you to go into H11 room. If you don't know, you ask or come after me.
Okay, just a second so I can move this from over here.
As I understood, there is a, yes,
It's okay? Okay, so my name is, hello everybody, my name is Paul Motora, and I'm here today to talk about combined genetic application with genetic programming in deep learning for detecting the fraudulent transactions. I'm not going to decompose the title right now, but I'm going to explain it a little bit further. Okay, so in the first case, what's a fraud? Actually, a fraud or a credit card fraud occurs when you have your credit card or your data stolen and some illegal transactions are being made in your name. In this paper, we will try to propose a solution for detecting fraudulent transaction from a really heavily unbalanced data set using neural network architecture. Also, for this neural network architecture, we will use some genetic programming, 4-eyes check, that's a banking principle that I will explain further, and some functioning modes to provide extra adaptability to the customer needs. Okay, I'm going to speak a little bit about the related work. After that, I'm going to tell you what we innovated in our research paper, some architecture and implementation, some experimental setups, the results, and some future work. Some future work that should be done. That's a lot. Okay, so if you are curious to read the first paper that I wrote down over here, it's really a broad paper about with about 10 years of research done in this fraud detection, let's say, field. In the article number 4 that I mentioned, we will see that a lot of other techniques are used with the same data set that we have. And the articles number 2 and number 3, what mentioned over here, even if it's a different data set, we can see the main problem that 2, 3, and even 4 have over here, and that's the precision recall curvature. You know, the precision recall curvature, maybe you ask yourself, what's that? That's the visual representation of the fact that precision and recall are often traded for each other. They don't have good values in the same time, as you can see over there. When precision is around 80% or 0.8, the recall is pretty small, and the other way around. Okay, as an innovation, we applied genetic programming in 2 steps, so we will have a great adaptability to the customer data. In the first step, or the first leg of the algorithm, we will try to adapt the actual architecture of the neural networks, and we will use again genetic programming for instructing each neural network. After that, we introduce the 4-eyes check system. The 4-eyes check system is actually a system or a principle that is used in banking environment that says that 2 different persons need to approve a manual payment so the payment is actually settled. That's maybe you've gone to BT or any commercial bank and they need each other's approval. That's the principle, and we implemented it over here in an algorithm. Okay, and the most innovative part is the fact that with the double genetic programming over there and the 4S check, we also have functioning mode. We have a functioning mode variable, and the final customer has the right or the opportunity to choose from 3 different functioning modes. That's increased recall, increased precision, or the balance mode. As architecture and implementation, as I said earlier, the system is based on flexibility and I said it with the double genetic programming. We had to do this because we tried in the past years or months to obtain actual data, some real data, but a commercial bank or even the national bank won't allow it. You often get only, and I say only, if you're lucky, some classified data. And by classification, I want to say that each column is only a number or not info at all, no background info, and everything is scaled down, you know. Everything that you have is between, let's say, 0 and 1 or -1 and 1. So it's not the actual numbers. Okay. As the last point over there, if you can observe, I said that extensive work using feature engineering was avoided. And that's because we don't have how to do it, how to actually do feature engineering on some numbers, and we don't have time. In a real-time payment system, there is no time to adapt each payment to make it suitable for the learning mechanism. Right here you can see that the outside knowledge is implemented using the 4S check system. Right here we don't have 2 different persons, but we can have 2 different opinions from 2 different neural networks. Those 2 neural networks that are consulted are actually the best 2 neural networks that we obtained after the training and testing phases using the genetic programming algorithm. Okay, and right there you can see that the recall, precision and balanced answers are actually generated, and the only thing the final user has to do is to choose the one that suits his business case better. Okay, and as I said it earlier, but I wanted to show the whole architecture. The functioning mode actually helps more like the business model, not really the performance over here. Okay, for the experimental setup and testing, we actually tried 2 different data sets. The first one contains real data, and it's shared in 2015 from the European card holders. We have 2 different days, 2 consecutive days of transactions from the credit cards, but the problem is everything is classified. You have 28 columns with no name, not relevant name, only with numbers, and another 2. The time column, but the time column is not actually the date or like the time of the day. It's time from the first transaction, so it's pretty useless for you. And the second one is the amount. The amount was actually scaled again to look like the others and to make the algorithm fast and to be sure that it can learn. It's not making decision based on a certain value. And the second data set is with some synthetic data, but you have all the columns in the world. Some extensive feature engineering was done over there, and it was adapted from 15 columns to 75 to make the learning process a lot easier. Yes, as my colleague said earlier, we respected the 80-20 rule. 80% of the data is for training and 20% is for testing. As you can see over here, as I said it, the extensive work was done on the second data set, that's the red line. And the red line, it's a little bit lower because it was a small data set and we had the time and the resources to actually use more neural networks in each training and testing phase. Actually, you can see right here in this table that the results are pretty much the same. The first phase or the first data set, you can see it's about 80% for an average, and over there it's the thing that I said earlier, we successfully eliminated that curvature, that precision recall curvature. We keep the precision and the recall at a constant, let's say 80%. And the second data set, with a lot of feature engineering done, better results, but not real payments. Okay, for conclusion and future work, actually we made proof that we can adapt our algorithm, our structures to the client's data, and to use some data that it's purely numerical with no background information. But we also made proof that the 4-ice check system really avoids the extremes, extremely high or extremely low, extremely good or extremely bad results. And the thing that really makes a system good is the consistency in time and the stability. The stability is done by adapting and again by consulting 2 different results, not only one, because we know that even that we are modeling systems, they can make great mistakes. Okay, and the biggest drawback, as it was and it is in the banking system, in the banking environment, is the fact that we have a lot of false alarms if we want a great security. That's the cost that we have to pay. For the future enhancement, I thought about introducing a third layer of genetic programming, and that third layer should be between the first and the second one, right in the middle, to select the best features for each neural network architecture before even starting the training. Okay, thank you. That was it.
Okay, I have a comment. So you want to put a third layer, but I didn't understand the role of the first.
The first one actually adapts the architectures. It plays with the number of layers, with activation functions. And the second one is used for actual training of each individual network. It's used for its genetic programming applied on the same structure that you have from the first layer, and it really
what does it change?
It changes the weights of each perceptron in the new network. So it does the training part over there.
That's not genetic, it's neural network.
Yes, it's a neural network, but it's a genetic algorithm, applied on the neural part over there. Yeah, the training can be done in that way, with a fixed structure and with multiple weights, and to see in time and over a number of generations which suits best.
Okay, other questions?
Okay, thank you.
No other questions? In that case, we will finish our session. Thank you very much for all the presenters and also for half of my colleague. And now, in approximately 15 minutes, we should go to room number H11, which is, for those who don't know, is close to the river. I will follow you. Mai faceți consumație pură până la fermea de serviciu, să curețe casă?
Sticlă de apă,
Sticlă de apă, o prăjitură sau ce mai e pe acolo, puteți goli.
Cheers.